tells you about the. So this diagram actually tells you about how the energy is flows from battery to the motor in one way, and then it goes to the wheels. Okay. At the same time, we do have the regenerative braking also. If you have regenerative braking, the energy also can flow in this direction. Go to the battery. That is also possible. So that's a huge concept, how we are regenerating from the wheel to the battery. That is done by regenerative braking. Okay, so regenerative braking is the in the future it's going to be mandate in all the electric vehicles, because even if you can save a very small amount of energy when you travel, that helps to the great extent to increase the range. So the range is very important, because range only is is the issue with the electric vehicle. So the main challenges in the electric vehicle, even nowadays also, even in abroad and here, the range. So once if you charge the battery, one full charge, the advertising factor is okay, 200 kilometer per charge, 300 kilometer per charge, 500 kilometer per charge. So that is the factor, the very important factor when we buy electric vehicle. So the main idea in regenerative braking is to improve the range. For example, if somebody says that, okay, sir, it is 300 kilometer per charge. Now I'm saying that with the regenerative braking, even if you can increase 10 kilometers range, it is very important. If you are about to, end up with your energy, but at least 10 kilometers you can still travel with, 10 kilometers even travel with the energy, whatever available in the battery, that is actually improved. Initially, it may be 300 kilometers per charge, but now it is 310 kilometers per charge. This 10 kilometers promised, the worst case, if the 10 kilometers promised by, regenerative braking, it is braking is going to be the mandate. Okay, so for that, technically we can understand that this motor is also act as the generator. At the same time, it can be the energy can be put it back to the battery. Okay, so that is where the design of this motor come generator. At the same time, there are research says that without adding any components, to the existing system, we have to include the concept of regenerative braking. Okay, that is more important. There are many methods of doing it. That anyway we'll cover later. Hello, everything is fine?
Yes, sir. Fine.
Video, audio?
Yes, sir.
Yeah.
Sir.
Okay. Okay. And these are all the very basic, very detail of the electric motor. Then we can also talk about the maximum torque, maximum speed of the motor, or the electric vehicle, the voltage rating of the electric motor, and what type of the electric motor. The general specification of the motor. But you can also talk about this is battery. So battery specification is very important. One is about the how much ampere hour it has. Then another one is the main factor which we have to compute is that how much unit the battery can have. Okay, that is the kilowatt hour of the battery. Another one is the nominal voltage. What type of battery, whether it's a lithium ion or lithium polymer, or it is lead acid, whatever it is. Okay, so these are the main very basic specification of the battery. Then we also have a C rating. So the C rating will tell about, this is the ratio of your power to the energy. So how much power you have, and how much energy you have. So this is the ratio of power and energy. So if you have 1 C rating, which implies that your kilowatt hour rating is equal to your kilowatt rating. So if you have 21.5 kilowatt hour, you have 21.5 kilowatt power rated battery. Suppose if you have 21.5 kilowatt hour, but your power rating is say 43, okay, 43 kilowatt. Your power rating is 43 kilowatt, but your energy rating is 21.5 kilowatt hour. Then you can say that it is a 2C rating. Your power is higher, your kilowatt hour is less. So you can actually put your kilowatt divided by your kilowatt. It will give you a C rating. So what it says that your power rating is more, but your energy rating is less. So your battery can capable of handling more power. What do you mean by more power? More power. So the voltage levels are fixed. The voltage levels of the batteries are fixed. Say 48 volt, 52 volt, 60 volt, 72, whatever volt you fix. That is like rigid source. Batteries are always considered as a rigid voltage source. Okay, the battery voltages are really fixed. Then what you can see, the voltage changes in the batteries are very less. If you take a 48 volt battery, it can go 46 worst case, and it can go up to 52 in full charge, open circuit voltage, full charge, 50. But then what about the power rate? Then only the remaining is what? Current and the ampere hour rating. So you have 20 amps and 20 ampere hour. That's what the remaining part. If you, what is this kilowatt? Kilowatt is voltage into current. What is in kilowatt hour? It is voltage into current into time, T. Okay, right? So, or you can even write time in terms of hours if you write. Then how we can say this is amps, the unit is ampere hour. Voltage anyway fixed. So, to say kilowatt, we talk about only ampere if you fix the voltage. Another one is for kilowatt hour, we take ampere hour. Ampere hour is written here. Okay, so if you have 216 ampere hour battery, if it handles 216 ampere, then it is 1C. But at the same time, 216 ampere hour, but the current rating, the current handling capacity of the battery, if it is 432 ampere, then you could see it is 2C rating. It says if you have a 2C rating battery, suppose if you want to charge this with this full current, if you pump 432 amps, if you give in half an hour, you can charge the battery. Is that clear? So this is what about 2C. So if you have a 2C battery, then you can charge the battery in half an hour. It is not important to have whether what type of charger you have, but your battery should capable of taking this much current. So that's why all fast charging battery, the C ratings are really high, more than 1. More than 1 means you can charge less than hour. But generally, whatever battery we buy, it is 0.25 C. It takes 4 hours to charge the battery. Sometimes it takes 2 hours. If it is 1 hour means it is great. It means 1 hour you can charge the battery. But sometimes people say that you have a fast charger, you have a DC charger, or you have a level 3 chargers, you can charge in 30 minutes. You can charge in 25 minutes. It's 15 minutes. These are all really, very large charging rated battery. That is, say 3C, 4C. It depends on your C rating. So these are all the extra things about the battery charge. Okay, and this is the basic comparisons of how a diesel, a general IC engine vehicle comparisons with the electric. Okay, for example, fuel type is here is diesel. Here we talk about the motor. This 1.5 liter engine capacity, and this torque, speed, range is very important. And the battery is important. And the motor size is. We are going to connect all these things. This motor rating, okay, motor power. You should know why this motor is 90 watt. You should also know about the range. 300 kilometer means per charge. kilowatt hour. The size of the battery is 30 approximately. Forget about this point 2. Voltage rating of motor is this. Cost is very important. This is 11 lakh. This is 17 lakh. Okay. The other parameters generally we don't mind. Even when you buy a IC vehicle, you only worried about what's a diesel or petrol. I mean, CC generally people may not know much about that. Maximum power, nobody's know. Maximum torque, nobody's know. Speed, maybe somebody interested what is the maximum speed the vehicle can go. Cost is important. Cost is a very important factor. Okay. And the other one is the motor power and the range and kilowatt. We are going to connect these three. Why we have this motor power is 95 kilowatt. The range is 300 kilometer. Kilowatt hour is 30. Is someone try to ask some doubt? K7 Jodi, your hand raised. Hello.
Sir, 1 second, sir. Keshavan Jyoti, sir, would you like to ask anything?
Yes, ma'am.
Keshavan, sir, would you
Yes,
like to
ma'am.
ask?
Nothing, ma'am.
No, actually, your hand is raised. That's why I got the.
Sorry, ma'am.
Okay, sir. Thank you, sir.
Okay, fine.
Sir, Shankararan, sir, please, sir.
Yeah. Okay. So yeah, this is the very basic the comparison. So we are going to deal about these three values: this motor power, range. Deal later in detail. Okay, and let us also look at some of the drawbacks of this EV. The battery life is one. Another one is
Sir, excuse me,
this
sir.
cost of
Sir, in your previous slide, you mentioned the battery rating is 30.2 kilowatt hours, sir. And your motor rating is 95 kilowatt. Whether it is sufficient to drive this much power to drive the motor, sir?
Yeah, it is. It is. See, we never talked about the battery power. It is the motor power.
Okay. Since there is a large deviation between the motor power and the kilowatt hour.
Not necessary, right? Kilowatt hour is how much kilowatt you release in 1 hour, for example.
Yes, sir.
You can always play around. For example, if you could deliver 95 kilowatt,
yes,
it's approximately 3 times.
Yes, sir.
So you can drive the car only in half an hour or 15 minutes.
Okay.
But the question is, why the vehicle is having 95 kilowatt?
Yes.
Are you going to use
because there is a large difference
always
between the input power and the motor power, sir. That is why I am asking.
It is not input power, it is input energy. You have to understand.
Okay.
See, it is kilowatt hour, right? It is not kilowatt.
Okay, sir. Okay.
It is kilowatt hour. For example, if a kilowatt hour, 1 hour, it delivers 30 kilowatt.
Yes, sir.
That's what it implies.
Okay, sir.
So how much time if you want to use, that much amount of energy is available.
Okay, okay.
It is not about the power of the battery.
Okay, okay.
Is that clear?
Yes, sir. Yes, sir.
Yeah. So we don't know how much, for example, in your house, we have a battery, right? Inverter, right? So if it is able to deliver the large power, you can connect the entire house to equipment to the battery. But how long it works? It works maybe in 10 minutes. That's all. But if you put only one light, then it can come hours together.
Yes.
Is that clear? So in the design, we are going to see why maybe we can ask the question, why Tata Nexon have such a huge motor power? Whether are they going to use, this is the peak power or this is the average power, or they have a large motor with them. Anytime their vehicle can be upgraded to any level by changing the battery. Is that fine?
Yes, sir. Yes, sir. Yes, sir. Thank you.
Okay. So these are all the one is the battery, just the factor which still keep us to look into this EV as a research issues or a challenging problem is that the cost of the EV is really large. That is one factor. The other one is about the charging time. The charging time is really high. Charging stations, the availability of charging stations is also less. We could not still see much charging stations because we don't know whether we could able to find out more charging station at present, and later maybe once the more number of charging stations comes, it is okay. But that is all infrastructure. These are all the infrastructure development. Okay. The other one is the range. Range is also very important because, as I said before, if it is only 300 kilometer per charge, but after that you have to wait 2 to 3 hours to again, for charging the vehicle. Again, it can. I think somebody is annotating my screen. Everything's okay? Had somebody writing something in the screen? I'm not doing it. Slide will give you an idea of what is the relation between this cost, the battery size, and the range. If you could see, these are all the not the costly model I have included, like Mercedes and Audi. These are all the available electric vehicle in Indian market. This is the Hector MG electric version, this one. The battery capacity is 44.5 kilowatt hour, and the range of the vehicle is 419 kilometer. You could see this too. Another one is the Tata Tigor EV, 21.5 kilowatt hour. For full charge of the battery, this can travel up to 213 kilometer. Another one is 30.2 kilowatt hour. You can travel 312 kilometer. That is Tata Nexon. Hyundai Kona is 39.2 kilowatt hour, 452 kilometer. Seems to be little, all you see, all these are all, somehow there is link. You can create a link. 39.2 kilowatt hour, 452 kilometer. With Mahindra E Verito, 21.2 kilowatt hour battery, you can travel 181 kilometer. Can you guess what could be the approximate unit spend for traveling 1 kilometer for all these cases, approximately? Can somebody tell what could be the approximate unit spend for all these cases? Some approximate value we can arrive now, because that is the main calculation, that all this vehicle, if you calculate, approximately takes 0.1 unit to travel 1 kilometer. 0.1 unit or 0.1 kilowatt hour. Is that clear? Or we can say 100 watt hour to travel 1 kilometer. Now you can see the price of 1 unit, maybe 6 rupees. Then it is 60 paisa you will pay to travel 1 kilometer. So all this vehicle, even though the makes are different, their maximum torque, maximum power, what type of motors, all these things you can leave. Yeah, cost also you could see all different cost. Maybe the cost not only depends on how much distance you travel, that is a range. This is what we call range. Range is very important. Okay. So irrespective of the cost, one is 23.7 lakh, another one is 24 lakh. So irrespective of all those things, you could see there is a connection. There's a connection between battery capacity and the range. So from this, what we can calculate is how much we spend to travel 1 kilometer. That value is very important. It says that 0.1 kilowatt hour means 0.1 unit or 100 watt hour. Yes, 1000 watt hour is 1 kilowatt hour. 100 watt hour you spend to travel 1 kilometer. This is what we are going to now calculate in detail, which actually tells us that this vehicle takes 100 watt hour to travel 1 kilometer. Is that clear? Yeah, if you have any doubt in this is the first part, this introduction. If you have anything in this, please let me know. I'm ready to answer, then we can proceed further. If you have any doubts on these basic ideas about battery, about the vehicle range, motor sizing, type of motors, if anything, if you have, you please ask, then I can continue with the second part of the lecture.
Sir?
Yes.
Sir, is there is any specific reason that they are using induction motor and synchronous motor apart from other motors?
Reasons, available. Actually, there are basic difference between the permanent magnet synchronous machine and induction machine, right? So almost both are like, it's a AC machine. There's no doubt. In one, this we have permanent magnet for magnetism, so that efficiency is little bit more compared to induction machine. But the problem with the induction machine is the controls. The speed torque controls are little involved in the induction motor. Unless otherwise you develop a very accurate controller, it is very difficult to have a the speed torque, the control over speed and torque. That's what they go for, the permanent magnet synchronous machine, where the controls are very easy. That was the idea. But now there are, after the Tesla tested the induction machine for their drive, they have a very patented control, and then the others also started using induction motor now, three-phase induction motor now. But otherwise, almost once you have a very good control technology to have a direct torque control or vector control methods, if you have accurate control and these powertronic controllers, I think almost both are same. It's not much difference initially, but now there are induction. You could see the comparison, right? Now even Tata Nexon also using a Tigor using induction machine, and Mahindra EV also using induction machine, but others are using permanent magnet synchronous motor. But technically there are a lot of technical difference on both, but finally the performance seems to be same, not much, if you have a proper control on induction motor. Is that clear?
So one more thing, sir. We are using three-phase permanent magnet synchronous motor. What about their lifetime? So since we are using permanent magnet due to aging,
these permanent magnets are for several years. They do not need to worry about that. They are making permanent magnets from a very rare materials, so it can come several years without losing its magnetism. Those material technologies are very advanced, very advanced, that we cannot even think of now. Those materials used in machines, brushes, in even brushed motors, also brushes, all those things are highly advanced materials. There's huge research on magnetic materials, right?
So why? Because I'm asking, Usually while you are teaching permanent magnet synchronous motor, the one of the disadvantages what we are telling is that due to aging, it will lose its magnetism. Likewise, we told, sir. So only I asked this question.
Yeah, but there are very fine materials now, magnetic materials. All these permanent magnets are made out of it. So motor technology excelled a lot that we could not even imagine, the sizing, all those things. The other part, if you could see the controllers, the pyrotonic controllers and the control technology also excelled in the very, that's why the efficiency of the motors are even going up and up, 87%, 90%, 92%. What else we want? Compared to IC engines, which have only 27% maximum efficiency from the fuel to the drive shaft. These motors are having 92% efficiency. So that point of view, this is nothing.
Thank you, sir.
Any other questions? Okay. So what actually, the second part of the lecture, what we are going to do is, we're going to calculate and the motor power. Okay. So how we can calculate the range? And how, range is what, how much unit I have used and how much distance I have traveled. So the previously, if you could see, we could say that so say this is starting from somewhere, this is a distance. Okay. Travel and how much energy I spent. How much energy used to travel this much distance. Maybe we'll take 1 kilometer. We can always make a per unit conversion. If you travel 1 kilometer, how much energy I use? Can you guess what if I do? I'll have this two calculations. Any idea of any of the attendees, so that it is very interesting to see. So if what I do, I can calculate the distance. For example, in your vehicle, suppose you have a car. Okay, you have a car. You have a meter, right? So that will tell you how much distance you have traveled. Is that clear? But how it is calculated, the distance? Hello?
So can you repeat, sir?
Participants can please, yeah. So that lecture will be interactive. So generally, how that is calculated? How the distance is calculated? It is always telling that 1 kilometer, 2 kilometer, like that, right? It is moving. Either your two-wheelers or your car. It is keep on telling you how much distance you travel, right? Sometimes you can set the trip 0. It is telling you some distance, right? But how it is calculated, I'm asking. Very simple. Some idea you may have, right? How the distance is calculated.
Sir, Shakti sir is saying by measuring the distance, by movement of the battery. Sorry, wheels. Rotation of the
Madam?
wheels.
I could not able to. Yeah, I think many questions are asked. I'll answer one by one. But anyway, yeah, rotation of the wheels. Yeah, that's correct. Rotation of the wheels, it's very specifically, technically, how we can say it. Rotation, what is that? In a technical term?
Maybe
Yeah. Yeah,
R-
Iswari said that RP, okay, nothing but speed, right? You come on, speed. You should know the speed. Okay. So if you know the speed, you can always calculate it. That is what the correct answer. RPM, rotation of the wheel, we can say that speed. Okay. So I have a speed. What if I do? I'll get the distance from the speed. From velocity, how you will calculate the position?
But if
Right? Very simple calculation. Yes, we're all teachers. See how from velocity we calculate the position.
by
You
integrating, sir,
integrate it.
by integrating.
Correct. You integrate the velocity, you'll get the position. Okay. But
Yes,
then
sir.
we also know integral constant, all those things are fine. Don't get into that. So if I integrate the speed, I'll get the position. Or let us say, in other word, we'll get distance. If you start from 0 to some time t, all those things. That is the solution. Very simple. So if you integrate the speed, we'll get the position. Come back here. How I can calculate the energy? How generally we calculate energy? For example, we have energy meter in our house. How it is calculating energy? How generally energy is calculated?
That is power into time, sir.
Yeah, exactly. So
What do
say should I say like this? When we integrate the power,
yes. Yes,
when
sir.
we integrate the power from 0 to t, what I'll get? I'll get the energy. That's all. Now the problem is solved. Speed profile and power profile, if I have, I can tell you how much energy used to travel this much distance. But in generally one vehicle, okay, two-wheelers generally we don't have, right? How much, how much, I think all the cars odometry you could see, what is the mileage? That factor is always is there. Average mileage is also will be there for a trip. Instantaneous mileage also will be there for a trip. That is very interesting. For example, if you click that, it says that, okay, now your mileage in odometry in your car, if you check, it is 20 kilometer per, 20 kilometer per liter. That distance, that is calculated. How it is calculated? It is calculated based on the consumption of your fuel. That is actually that you can always convert into energy. But we don't really look at in terms of energy in the fuel, we look in terms of a liter. But that is directly connected to the price, the oil price. But now here, this is our electrical units, right? So we can always convert it to energy. Here also the power is integrated. So what generally if you look at the curve, over a period of time, what I have is time velocity. Okay, either the car velocity may be kilometer per hour or maybe whatever it is. Start from 0, some distance we travel, come back to rest. Similarly, you have a time here, you have a power here. You start from 0, it will go somewhere, it will be something like that. See, this is 0 to a capital T, 0 to a capital T. What we'll do here, this velocity profile, you please take the area under this curve. Also area under this curve. What is the area under this curve? If you take nothing but integral of V of t, 0 to capital T, will give you a distance t. Similarly, this fellow you can take 0 to capital T, this power P of t will give you energy. This is distance, maybe in kilometer, this may be in kilowatt hour. That's all. So what is important here is this two profile. If you give me the velocity profile and power profile, we can calculate. So now take an electrical vehicle. Electrical vehicle, how we can calculate the distance? For example, we have a electric vehicle in our lab. For example, we have an electric cycle, we have an electric bike, we have an electric car, our own laboratory made electric car. How generally we calculate the distance, how much unit it comes for a distance, for a particular to travel a particular distance? We actually mark. We'll mark a point, for example, from the department to another main gate. We know how much, maybe it is 1 kilometer. Exactly. How we calculate 1 kilometer? We take a two-wheeler, you reset it, you travel, and wherever exactly it comes to 1 kilometer, stop it, mark the point. You now take a vehicle. What we'll do in the vehicle, we'll connect a voltmeter, we'll connect an ammeter, and we also record it in a processor. So the voltage and the current readings are noted. We simply multiply that. We'll take the power over a time. Over the time is what? We don't take velocity. We never integrate it. But that you can also do that. How you can do that? There are softwares now in your mobile. You can download that software. You can keep in your car or in your bike, in your pocket. You set it to 0. Initially you start. Then you travel. It will completely give you your velocity profile because you have a vehicle, your mobile phone is having an accelerometer. And not even that, it can directly connect to the GPS. GPS will tell you what distance, where you are traveling. That is the original speed. That is the exact speed. If you don't have any problem with your connection to the GPS, whatever velocity tells by the GPS is accurate than whatever velocity your vehicle is telling in your odometer. Why? Suppose your wheel is slipping. You are suddenly applying brake, your wheel slips. When the wheel slips, the velocity, whatever shown in your vehicle is not correct. Okay, but the vehicle, whatever velocity shows by the GPS is correct because GPS measuring your movement from the another frame. But this is your actual speed of your vehicle, you are measuring from the wheel that is in the vehicle frame itself. So there may be a mistakes to measure the velocity. Okay, so that is the velocity measurement. That velocity you can integrate. That is fine. Then integrate it to give you a complete trip. The power we can always calculate by doing this. So it's a very simple calculation for doing this. How much energy it consumes to travel 1 kilometer. Maybe the cycle can consume very, very less, 0.01, 10 watt hour to travel 1 kilometer. The e-bike may consume maybe 30 watt hour or 50 watt hour to travel 1 kilometer. The electric vehicle, what we have, can consume 70 watt hour or 700 watt hour to travel with. If you have a normal car, it can take 100 watt hour or whatever it is. Okay, so it depends. So this is how we calculate. So the basic idea here is to have these two curves, power curve and velocity curve. But how we know that this much power the vehicle consumes? That is important. Power curve you can always calculate. Velocity profile you can always do it for an existing vehicle. But now for a design, how you do it? For design means people will give you a design. Okay, this is the weight of the vehicle. How we can calculate the power based on what you actually you are going to say that this vehicle need this much power. Existing vehicle, calculating these two things are very easy. You buy a vehicle and you calculate it. But suppose somebody asks you to design a vehicle, how we go about it? That's where the complete calculation. Is that clear? If you have any doubt on this too, this is the fundamental. If this is clear, then you can do all the further calculation in a very simple way. It's not an issue. Yeah, fine. Any questions on this concept? These two are clear to everyone? Any questions on these two concepts?
Professors, please. Ramya ma'am, would you like to ask any question?
Okay, fine. Anyway, I have some.
Please, sir.
Yeah,
please.
fine. Yeah, I'll proceed. Okay. Now, yeah, for that we need a very basic calculation, very basic Newton mechanics to understand all those things. Okay, this is a very simple vehicle dynamics. Okay, so we are going to do a force balance, and we are trying to understand from the very basic concept that how much power a vehicle needs to do a job. But to do what? to push the vehicle to a particular velocity, you have to travel in the particular speed picture. Okay. Now from this, you can take a force. What is that? This mass into acceleration equal to the traction force. This is the resistive force. The resistive force you can always write into this three portions. One is the wheel friction. Another one is the drag force. Another one is the force, the resistive force because of the slope, or we call grade. Okay. Grade, drag force, wheel friction force. These are all the three important resistive force. There are many other small components in detail, but we don't need to go about this. These three are the big portions of the resistive force. You look at this. This is the mass of the vehicle, gravitational acceleration due to gravity. This is the rolling friction, what we call rolling friction, and this is the air density, area of the vehicle, drag coefficient, vehicle speed, wind velocity. Another one is the mass, acceleration due to gravity. This theta is the slope. If you could see this figure, theta is the slope. Okay. So when you try to push the vehicle forward by applying a thrust force, Ft, that we are applying. How we are applying? Either you push by yourself, or you have an IC engine, or you can have an electric motor. It depends. This calculation is a very general calculation. It is not for electric vehicle. But finally, we are going to calculate the power and energy, and then based on that, your battery capacity will go. Okay. Now this is the portions. Okay. Now when you put everything together in this formula, say 1, what you will get? The tractive force equal to mass into acceleration. This is to push the vehicle into particular acceleration. All other things are resistive force. So if you don't apply a force to overcome all these things, the vehicle will not move. First, you have to apply the resistive forces in this portion, then only the vehicle can move. This is the force needed to move the vehicle, to accelerate this much speed. That is very important. These are all the factors. Okay. Now, how you calculate this? How you calculate that? To calculate this f of t, what do you want? See, mass is constant. Mass is the mass of the vehicle. It is constant. Acceleration is what? Acceleration is the time-based quantity. There is a variable. That variable depends on what? Your velocity. Again, mass is a constant. Acceleration due to gravity anyway is not going to change. The rolling friction is constant. Theta is some slope. For example, we can take the case where the vehicle is traveling in not a slope, in a plane without slope. So this fellow will become 1. This fellow will go to 0. So we can eliminate these 2 terms. Now, what about this? Rho is constant, A is constant, CD is constant, V is another velocity. So this entire term you can always write is some function of, say, I can write h of V of t. That's all. If you plug V of t in this formula, you can calculate f of t. So V of t is what? The velocity profile of the vehicle. The velocity profile is what? It exactly tells you what you are doing. You are starting from rest, you are traveling, you are accelerating, decelerating, braking, all this velocity profile. So if you give the velocity profile of the vehicle, we can calculate the force. Then how we can calculate the power? Power is very simple. Power is equal to force into velocity. Again, it's a function of velocity. That's all. Is that clear? Okay, so we simply multiply this the entire force into velocity, you will get. Again, what is this one? Is nothing but P of t is equal to whole function is there. Put all these constant in that. If you give V of t, we will calculate it. So if you have a computer program, if you feed V of t to the computer program, it is going to give you P of t. Is that clear? So if you type this formula in a MATLAB or whatever it is, if you feed V of t, you will get P of t. Very simple. So now you go back. You go back here, and if you look at our previous explanation, all those things, what is there? Yeah, this V of t and P of t, there is a connection between these two. What is that? Either if you give this much power, you can follow this velocity. So, but this is depends on what? This is depends on your vehicle. Either it could be a e-cycle or e-bike or electric car, whatever it is. So depends on that, this relationship are developed. Velocity to a power profile to a velocity profile. So both vice versa. So if you feed velocity, if for electric vehicle, this is different. For electric cycle, it is different. Electric wise, if you buy an electric bike, if you apply a power in this manner, you will get this velocity profile. Is that clear? Okay, this is what fundamental. So initially we try to calculate how much you to travel 1 kilometer. That is the simple problem we started solving it. Then later what we found that the relationship is very simple. The relationship is based on the velocity profile and power profile. So if you the vehicle, you integrate it, you will get the position, distance. Similarly, if you have a power profile, you integrate it, how much power it consumes over a period of time is nothing but your kilowatt hour. So that two things are two variables are very clear. Then we are trying to give a connection between these two variables. If you give a power profile, is it possible to generate a velocity profile? Yes. If you give a velocity profile, is it possible to generate a power profile? Yes, provided what type of vehicle is that. So it depends on the vehicle. This is where the vehicle comes to picture, right? Otherwise, there is no point. If you have some velocity, some power profile, what is the link? Why cycle is consuming less power to travel 1 kilometer? Why e-bike is consuming little more? Why electric vehicle, a car consuming little more? Why electric bus or electric truck consuming more? It is because of the connection between the velocity and power profile. Okay, that will give you a complete picture. Now, but how to do it for a given vehicle? How we generally do the calculations? Okay, that is the other this. How we'll do that? So the next idea is to calculate the power for a given velocity profile, not a reverse. Reverse calculation is what we generally do. What we do, we buy a vehicle, we buy a car, then we drive the car. How we drive the car? We have to follow some velocity profile. What the velocity profile? Starting from rest, then we accelerate, then in some traffic signal we apply brake, we decelerate, then sometime vehicle come to rest in the signal, then again we accelerate, then in the highway we will simply follow 80 km/h, 100 km. These are all the part of the profile, but we never do a design, right? So we as a driver, we apply a pedal accelerator, it takes some power from the fuel, and we do it the same over a period of time, we reach the destination. So when I travel from my home to the institute, it takes 25 km. These 25 km, I don't know how I drive. Finally, there is a velocity profile, but the total distance traveled is 25 km. Every day the velocity profile can change. Every day the power produced by the vehicle, by the engine is different. That is the reverse calculation. So this much power, if I apply, this much velocity will get. Or I have some velocity profile in my mind, I do it, this consumes this much power. Okay, so in between model, I don't know why this much this velocity profile is followed when I do this, or why this much fuel consumption is taken place when I follow the particular velocity profile. This we don't know. This is where the connection. Suppose somebody asks me to design this, I will do this. Okay, so what I do every time, I have to cook up the velocity profile. I have to cook up the velocity profile means what? You are telling that, sir, you start, then you accelerate the vehicle 50 km/h speed, you have to cruise, but the acceleration is say 30 km/h in 20 seconds, 30 seconds. So always the sports vehicle, they always advertise that now 300 km/h in 10 seconds. So 10 seconds, you can reach 300 km/h. That is what? Nothing but the acceleration. So you can always hook up. I'll show you the actual. Suppose if I have a velocity profile like this. This is what 0. Finally, I have to cruise the vehicle at 75 km/h. Okay. Is it visible to everyone? Should I make it a little bigger?
Visible, sir.
Is that okay? Suppose you see, this is a cooked up velocity profile. This I am assuming. I have a car, I have a vehicle, and I have to follow this profile. Then you can ask, sir, how you exactly follow the profile? I have an industrial setup. I have a proper driver. That driver will drive the car exactly to follow this. Okay, starting from 0, you could see this is, for example, 30 km/h in 10 seconds. The slope is nothing but your acceleration. What do you mean by the slope? This is v of t, this is t. So if you take dv of t by dt, you will have alpha in that formula. This is nothing but acceleration. dv by dt is what? Slope. The slope I calculate. What is slope? 30 km dv, the width, del v by del t. What is del t? This one. What is del v? This fellow. This slope is constant. You can calculate anywhere. The slope of this line will not change. Okay. So what is that? You can tell it may be 40 km/h in maybe in 14 seconds or 30 km/h in 10 seconds. This is not meter per second, kilometer/h. Okay. So 5, 10 kilometer or not 10, maybe 15 kilometer in 5 seconds. They all are same. All are same. So from this you will calculate alpha. Your all other parameters are available. Mass of the vehicle, then you have a density of the air, you have CD, everything's are there. Everything's are there. All this you put into the formula, you feed this V of t, will get exactly P of t. Okay, you come back here. You see, this is the different portions in the power formula. This is power required for acceleration. This is power required to overcome rolling friction, drag force. This is the total power, the red one. You could see. So initially the power is increasing and it is coming to the peak. After peak, suddenly it falls. Why it falls? Because we are cruising. When we cruise, the power required for acceleration is 0. Why power required for acceleration is 0? When you go with a constant speed, dv by dt is equal to 0. So in the highway, you are traveling in a constant speed, say 100 km/h. What happens? The velocity is constant, so acceleration is 0. When acceleration is 0, you see the formula. We have the thrust force into velocity. In that formula, you could see m into alpha. Alpha is nothing but the acceleration. That time will go to 0. That's why this theoretically it has to come to 0, but but then you see this yellow is the one for the acceleration. Acceleration power comes to 0. And you could see the cruising power overcome the drag force. That is the green one. This is constant. The rolling friction is constant at every time. So this is so now you have a power curve, that red one. Now you take the area under this curve, this power curve, you will have the kilowatt hour. That's all. And if you calculate the area under this curve, you know what is the distance traveled. So very simple. Okay. Now you can ask for the motor. 4 into 10 power 5 watt you should have. So it's about 40 kilowatt. Am I right? Correct. So this peak power, this is the peak power. You understand? This is the peak power calculation. Peak power is what is the peak power? The worst case. What is the maximum power the vehicle need? To calculate the maximum power, what we need is the maximum possible profile. What is the maximum possible profile? I have to accelerate the vehicle with its maximum acceleration. Then you can ask, sir, how you can calculate the maximum acceleration? That is given by the specifications given by the designer. So they have to tell us that We want to design a vehicle such that that vehicle maximum acceleration is 30 kilometer per hour in 10 seconds. Okay. What is the maximum speed of the vehicle? The maximum speed of the vehicle is 75 kilometer per hour. If these two things are given, then you are going to generate a velocity profile that will give you the maximum possible drive cycle. Okay, this velocity profiling technically what we call is the drive cycle. The technical term for this drive cycle is this one. So you can take a drive cycle for in Chennai city, Mumbai city, Kolkata, Delhi, and you can have your own drive cycle with your mobile when you travel for a trip. Okay, so if you have a drive cycle, either you cook up the drive cycle or you can have your own drive cycle. If you have your own drive cycle, that is the actual drive cycle. This is a cooked up one. This I can do it in the industry, factory. After I design the vehicle, I can check this via a proper driver. He follows the maximum, or you can in your vehicle you are going to check. You purchased a vehicle and said that, sir, this vehicle will go 300 kilometer per hour in 10 seconds. You check it. How you will check it? You take a proper road where nobody is there. You check it. And also it tells that the maximum speed is 500 kilometer per hour. Yeah, you can go 500 kilometer per hour to check it, whether it is possible or not. How we can check your motor or your IC engine capable of giving that much value? Yes, you can always check it that. Okay, but how we go about the normal this one? So normally what we do is we'll have same formula, but we'll have a real life cycle. Yeah, this is the actual drive cycle. Drive cycle is the velocity profile is what we call as a drive cycle. So technically it's called drive cycle. See, this is the drive cycle. What is the drive cycle? See, you start from rest, you have an acceleration. Again, there is another acceleration that is called cruising, constant speed. Then you have a deceleration, come to another speed, cruise it, decelerate, come to another speed, come to rest. So you can divide it into one is rest, acceleration, deceleration, braking. Brake is nothing but deceleration, both are same. Cruising, constant speed. So any drive cycle can be split into. This is the original drive cycle, not the cooked up one. That drive cycle will tell you to calculate the maximum power that your vehicle need to achieve this. But we never operate the. Have you ever operated your two-wheeler or your car with the maximum power what is available in the engine? No. We could never tested it. We could never given a full throttle in a highway with full speed. We never tested that. So that is for the worst case. That is you are trying to check the engine capacity. But the regular drive cycle is what when you travel for a trip. That is a regular. It may sometime it can touch the peak power, but not always, or it is always follow this. So what we mean by the worst velocity profile is if you have the velocity profile of what we were cooked up. We have said something like that, right? But all your other profiles below this, all your curves are below this only. Similarly, if you calculate the peak power, we have done something like this, right? All your real, I mean the actual power. This is the peak power. The actual power calculations all are below this only. It will never go up at any time. All your curves below this. Okay. So this one will be, for example, this velocity profile can be something like that. Maybe your actual profile may be something like this. You see, your all curve will be below this. This is the first case. Okay. So after you do that, your calculation will tell that if you really put that into a table, where is it? Yeah, either this you can, I don't know why you forgot to include that. Like that, there's a table. Okay, you can always put every actions in a table, that initial time, final time, initial velocity, acceleration, next acceleration time, starting from 20, 26, initial velocity 0, acceleration, this much energy, utilized, this is a distance traveled. So if you calculate all these things, finally it will tell you the figure. How much energy consumed and how much distance you travel. So now, after you calculate that, this is the one example. For example, after you calculate that, it consumes 0.1 unit to travel 1 kilometer. Okay. Then you suppose you want to keep the distance, you want to keep the range of your vehicle 10 kilometer, then it is 1 unit. If you want to keep the range 100 kilometer, then 10 units. Battery capacity, I'm telling, how much energy you are supposed to use. 0.1 unit for 1 kilometer, 1 unit for 10 kilometer, 10 unit for 100 kilometer, 20 unit for 200 kilometer. So if you want to have 200 kilometer range of your vehicle, you should keep 20 kilowatt hour battery in your vehicle after you do this calculation with the allowable motor size of your peak power. So this is the link between the battery size and the distance travel and your motor size. Is it clear?
என்னம்மா பாக்ஸ்ல இருந்து நம்ம வீட்ல வெளிய வைக்கணும் வீட்ல இருந்து box. அவங்க குழம்பு வச்சு சாப்பிட்டு
Okay, and this is the end of the lecture. Yeah, now you can ask any questions related to that. Any question in the chat box? Only half of the slide is shown in the screen, is it? Now I have made a blank screen to draw something based on your questions.
Dear professors, any questions? Anybody in the group?
Yeah, you can ask any questions now related to the entire lectures about the
Yeah.
sizing, motor sizing, all those things. I am ready to answer.
Sir, Vijay Deshle sir asked, what is the battery capacity?
What, madam?
Battery capacity, regarding battery capacity, Vijay professor asking, sir.
Is it? I'll in the chat box. Okay.
Yes, in the chat box.
About battery, yeah, battery capacity is now, you know, right? So that's what I'm telling. So 0.1, yeah. So now we have 0.1 unit to travel 1 kilometer. Now you give 1 unit, it means 1 kilowatt hour, right? So 1 kilowatt hour for 10 kilometer distance. So if you want 100 kilometer distance, you keep 10 kilowatt hour battery. So 20 kilowatt hour battery for 200 kilometer range. So this is the battery capacity. So this is we calculated based on the calculations, whatever I had shown you. From this you have to arrive. So if you want to keep the range of your car is 200 kilometer, you should keep 20 kilowatt hour battery.
Sir, Sharmi Bhatt ma'am, could you please
Yeah.
highlight on BMS?
Yeah, BMS. BMS is the separate entity with the battery that you cannot detach from the battery. So the main aim of the BMS is to protect the battery from both. Protect the battery from charging as well as discharging. So what the battery management system will do, the battery management system will measure first some of the parameters of the battery. What are the parameters? It measures the voltage of the battery, voltage of each cell. That's what its main job. Because cell voltage 3.2 to 3.7 lithium ion battery cell. That voltage can be measured easily by a IC. Because IC can withstand 0 to 5 volt. Okay. So voltage it will measure. It will measure the current. It will measure the current sometime of the pack. It is not measure the current individual battery cell current. It measure the current of a pack or the module. And it can measure the temperatures of the entire unit as a single measurement, or it can measure the temperature in a different place. It depends on your battery management system, how good your battery management system. Okay. Then it also has two charging and discharging switches, MOSFET switches. It will close and open based on the different conditions. These are all the main function of the battery management system. So the another one is some of the controls. One is the measurement, another one is the control. What kind of control it can do? It can disconnect the battery. When there is a problem with the charging or overcharging, or it is over current, all those things it will discharge. The over temperature comes, it can discharge, disconnect the battery. Okay. The other important point for the battery management system is it has to balance the cell balancing. Cell balancing, we have two types. One is active cell balancing, passive cell balancing. Passive cell balancing, if one cell voltage is lesser than the other cell, all are the nominal voltage, what it will do, it will try to drain other cells also to that level. For example, one cell is 2.7 volt. All other cells are 3.2. What this passive balancing will do, passive balancing will discharge the remaining cell such that all the cell will be in the lower cell potential. That is the passive cell. Active cell balancing is pouring some of the energy from the cell which has more voltage to a cell which is less voltage, so that pouring that energy so that the cell voltage levels are balanced. That's active balancing. But active balancing involved more circuitries. Passive balancing is a resistor. Just you bypass energy over resistor, it will dissipate via heat, and then it will be. That is the balancing part of BMS. The other part of BMS is it has to estimate the SOC, state of charge, and state of health. That is a very huge topic. Okay, so these are all the content of the BMS. This can be done through a simple IC, processors, many things. We are actually developing a BMS for a US-based e-bike right now. So US-based company, we are developing a BMS. We have our own algorithm, circuits, all those stuff. Yeah.
Sir, Sheetal Parmar madam asked, is there any connection between charging methods of battery with the time?
Yeah, see, charging method, you have to first understand there are three types of charging based on the power level. Power level means, as I said before, power rating of your battery. Low level charging, medium level, higher level. Low level charging is with a very low power. So for example, your battery, if it takes 200 amps for an electric car, 200 amps if you give in 1 hour, 200 ampere hour, it's full rated battery. It's full rated your charge. Okay. But lower power rating chargers will take 10 hours, 10 to 12 hours. Then DC charging, second level charging as well as industry charging, both DC, fast charging. DC charging, it takes 2 hours or 1 hour, like that. Fast, industrial charging, fast charging, take half an hour. But again, these are all depends on your battery C rating, battery power rating. If your battery is not 1C rating, you cannot charge less than 1 hour or 1 hour. Your battery should have 1C rating. For example, if you take your old mobile, if you charge with your new charger, your mobile battery will go after a few charging cycles. Why? The C rating of your old mobile is very less, but nowadays these fast chargers are there. It can charge in 1 hour. It can charge in 2 hours. If you 1 hour, generally charge in 1 hour means your battery is 1C rating. So compatibility, the synchronization of your battery C rating and the charge is very important.
Sir, Sagar sir, how to start with battery thermal management system?
See, thermal management system is like, this is the part of the battery management system. So generally for a small battery, we simply measure the temperature either in one place, and whenever the battery get The high temperature, it will disconnect the battery for a safety. But in a car or a bus, we have a separate thermal circuit. So we have temperature sensor in many places. We have a coolant that is circulating over the battery surfaces. Either it could be air cooled or it could be liquid cooling or sometimes refrigerant cooling. So it's a complicated circuit. It's like our cooling system in our IC engine. Same for a car, for a bigger rated battery. Yeah, SOC, SOH, yeah, already I told you it is state of charge and state of health. State of charge of the battery is very important because that is what that will only tell you about the range. So if 80% is over, 50% is over. So if you have 200 kilometer range, if your battery capacity 50 percentage SOC, you will go only 100 kilometer. So it is very important that it's a fuel age, your fuel gauge. But estimating SOC is a very critical this. Generally, whatever the basic algorithms we have is the Coulomb counting. We just measure the open circuit voltage, then we integrate the current. Both based on negative and positive, it charge or discharge. But the problem is, if there's an error in your charge current, the current measurement, it can give you a wrong estimation of SOC. That's why a model-based SOC estimations, then the Kalman filter-based SOC estimation, many things are available. Based on that, we can also predict SOH. SOH is the profile of the battery over a period of time. So if your battery is following a proper pattern while charging and discharging, but after some time the pattern is changing. When you charge the battery, initially it seems that it is taking 1 hour to charge, but suddenly it takes half an hour to charge. Then something is wrong. So we have to compare profile at every now and then. If there is a deviation over the profile, a large deviation over the profile will tell you about the health of your battery. The battery health is not good. Okay? There are many methods.
Sir, Amol Shinde, professor, why hub motors are not used in cars?
Yeah, hub motors are used. Hub motors are used in a small capacity car, but nowadays also they are thinking to use the hub motors for a large capacity also. But the problem is that if something goes wrong on the wheel, because wheel is the one which is connected to the road, right? So if there is something over the wheel, the entire motor get damaged. That's why for a higher rated, because it's a costly affair, right? Motor is really costly. When you started using a hub motor, you have to be very careful. That's why they are keeping motor in a separate safe place and connected to a wheel by a small drive shaft. But the recent research is going on to use the hub motor for a large rated motors. But now for e-bikes and all, it is a hub motor. For e-bike, it's a hub motor. The cycle also, it's a hub motor. Only car, they have a separate motor.
Any more questions? Professors, please. Sir, can you provide the details of battery charging control techniques? Shrital Parmar, professor.
Battery chargers, there are two types of charger. One is charging method. One is the constant current charging. Another one is the constant voltage charging. So if the battery SOC is very less, we simply pump the current. Like you have a water tank. The water tank is empty. What you will do? We'll simply pour water with a constant rate. We'll simply say that 100 liter per hour rate. We'll simply pour the water. Okay, that's a constant current charging. Once the battery level comes to 100%, close to 100%, we will give a constant voltage charge. We'll keep another tank close by that. We'll simply connect. So slowly the current will go, and eventually the current comes to zero when both the potentials are same. So we have a constant current charging, constant voltage charging. Constant current charging, how much current you are pumping to the battery is important. That depends on your power of the battery or C rating of the battery. Okay, this two profile has to be followed. So your charger has to be programmed such that this profile has to be followed to get a proper battery life. Is that fine?
Sir, Professor Aditya Kale, very interesting topic covered. Sir, please forward related PPTs or books or PDF.
Yeah, I'll send this
material.
PPT. Yeah, I'll share some of the books also, e-books.
Sir, Jairaj Professor, how to extend battery life?
Yeah, if you no need to extend the battery life. If they're saying that it is a 1000 cycle charge cycle, even if you keep 1000 charge cycle, it is fine. For that, you have to, your battery management system should be proper, your charger should be proper, you should have to load your battery also in a proper way. That battery management system will take care of that, because you cannot simply charge by violating BMS. In between, BMS will be standing. BMS will never allow, even if you are discharging the battery in an improper way, you are charging the battery improper way, BMS will simply disconnect it. So if you have your proper BMS, yes, your life will be not improved. Your life will be guaranteed as what it is. It is happening in many of our, one of our US customer is saying that his cycle battery is draining very fast because the BMS is not working properly. The BMS don't work, your battery drain very fast because one cell voltage is imbalanced, right? So it simply pull down all the battery voltages. So BMS plays a very big role, and BMS also will tell if there is a battery problem.
Professor Marisham sir asked regarding your contact details, sir.
Is there any production technique for battery? Production technique is over current, over voltage. Those are all the production technique. The BMS will protect the battery in that way. Mean depth of discharge indicator, over voltage indicator, over current indicator, over temperatures. Okay, all these things will be programmed properly to disconnect the battery from the source or from the sink.
Sir, Sharmi Professor, any guideline for EV in India?
Guideline means what?
Professor Sharmi, can you unmute? Maybe the guidelines followed to implement electric vehicles in India, or maybe it's the question.
Yeah, there are a few guidelines in the sense how much energy it should consume. There is a guideline. There is a guideline for region to braking. There is a guideline for this charge port, compatibility. Those things are there.
Professor Sharmi, are you clear with the question? Okay, okay. Please chat with Professor ma'am.
I think RI has the guidelines. RI, if you go to RI website, for example, if you are, I'll tell you the simple thumb rule. What they have is, if you have 1 ton weight vehicle, just thumb rule. Vehicle should take only 0.1 unit. If it goes above 0.1 unit, they will not allow. Similarly, if you have a 10 ton weight, example bus, if you take 10 ton, you should use 1 unit to travel 1 kilometer. That's the thumb rule. Like that, there are guidelines.
Professor Sharmi, hope the answer maybe cleared your doubts. Thank you, ma'am. Any more questions? Professors, please. Sir, please proceed, sir. Shankar Narayanan, sir, please proceed, sir.
Yeah, that's all, madam. That the lecture is over.
Oh, okay.
Yeah. The minimum portion what I would like to cover.
Sir, any more questions? Sir is available to us.
If you have, if you have contact me.
Thank you, professors. Thank you so much.
Yeah.
Sir is giving his contact details.
My lab website is CSRL.
Professor Marishan, sir, please. Sir is giving his contact details.
This is the lab web page. This is the mail ID. You can contact me if you have any queries. If you want to design an EV, if you want to design an e-bike, we have all the capability in our lab. Okay. Anything else?
Sir, thank you so much, sir. Shankaran, sir.
Yeah.
Thank you, sir.
Thank you, madam. Thank you for the opportunity. And yeah, I thank the participants because they have posted very interesting questions. Because very rarely I used to have questions in the session like this. So it's nice to have such a participants.
On behalf of GRT Polytechnic College and Instrumentation Control Engineering Department and self, we are highly thankful to you, sir. We know people are highly engaged with your activities. In spite of that, with your schedule, you have spared your valuable time and it really gave a mathematically oriented explanation towards these sessions. Quite informative, sir. Thank you so much on behalf of the participants and self. We are very much thankful to you, sir. Thank you so much.
Thank you, madam. Thank you.
Thank you, sir. I request all the professors to fill the feedback link, which is shared in the chat box before leave the session. And we will meet by 11:30 for the second session.
Yeah.
We'll have a 15 minutes break.
Thank you, team. Yeah.
Thank you, sir. Thank you so much.
Thank you, madam. I am leaving. Thank you.
Thank you, sir. Thank you, sir.
Sir, thank you, sir. Thank you, sir.
Thank you.
Professors, please fill the feedback link, which is shared in the post box. And we have a 15 minutes break, then join by 11:30. Thank you all.
Okay, ma'am. Thank you. Thank you.
Ma'am,
Yes, sir.
ma'am, please once again post the feedback form, ma'am.
Sure, sir. Sure. Marison, sir, please.
Madam, put it in the WhatsApp group.
Which one, sir?
Feedback link, ma'am.
No, sir, we can't, sir. Sorry. We can put it in the chat box here itself, sir.
Okay, ma'am. Thank you.
Thank you. Thank you very much.
Ma'am, good morning, ma'am.
Please, sir. Shiv Krishnan, sir, please.
Ma'am, actually, I am already requesting you that previous sessions will be can you possible to update in the YouTube channel, ma'am?
Yeah, sure, sir. Actually, we are also yet to leave, and yesterday it was heavy rain here. So we have, recording all the sessions and saving, sir. Probably we will share all the recordings with you, sir.
Thank you so much, ma'am. Can you please, after completion of updating, can you please update on the WhatsApp group, ma'am, that link?
Yes, sir. We will mail to you, sir. All the links we will mail to you.
Oh, thank you so much.
Because in the WhatsApp, sometimes the memory may not be sufficient. So we all, to all the participants, we will share the material to you, sir. Video links, everything.
If you possible, means can you please share that the PPTs also?
PPTs, people are not sharing, sir. That is why we are recording everything.
If possible, means we can do it.
Sure, sir. We are requesting all the professors, but till now we didn't receive any PPT. That is the problem.
Okay, thank you. Thank you so much.
Yes, sir. Yes, sir.
ગુડ મોર્નિંગ ઇલાજ કેમ છે મજામાં છો શું લેવા આવ્યો છે બધું લેવા આવ્યો છે કે શું மார்க் போடுறதுக்காக வந்தது நாங்க கேட்டுட்டே இருக்கோமா கணேஷ் கூப்பிடுறது கேக்குதா இல்லையா?
Good morning, Mr. Rajkumar.
Hello, ma'am. Good morning.
Good morning, sir. 2 minutes, sir. As the
Sure, ma'am.
participants are joining, we'll wait for 2 minutes.
Yes, sure.
Thank you. Good morning, professors. Welcome back for the second session of second day of our ATL sponsored FDP on electrical vehicles. Now we have the guest of honor, Mr. Rajkumar, Senior Application Engineer from VI Solutions, Bangalore. Now the brief intro will be delivered by Mrs. Uma Maheshwari of our department. Uma ma'am, please.
Thank you, ma'am. Welcome back for this second session of this day. For this session, we have Mr. Rajkumar, Senior Application Engineer in VI Solution, Bangalore. Sir has completed his engineering in Tripoli from Anna University, Chennai. His major responsibility is supporting various industries in implementing several turnkey systems and system integration projects using NI product. And he is also handling major responsibility of improving the quality of engineering and science education and eradicating the impoverished method of education and inculcating the interest for lab view. He has traveled far and wide throughout India and has delivered thought-provoking lectures which inspire the students and kindle their interest towards lab view, and also visited 75 engineering institutions. He had conducted more number of hands-on training to engineering students of various branches on lab view basis and data acquisition. He also conducted many faculty development workshops on various trending technologies, including embedded and control design, image processing, etc. He has delivered 100 plus lectures on experiential engineering education on varied technology topics. His area of interest includes measurement and automation, sensors, data acquisition and signal conditioning, FPGA-based embedded system design, power electronics. I like to extend a warm welcome to Rajkumar sir. And sir, you can take over the session, please. Thank you.
Thank you very much, ma'am. Dignitaries and the participants of this program. It's a really honor to be a part of this ATL FTP program and to convey my, the stuff which I've been learning and continue to learn as a part of this FTP program on my, ideas and lectures on implementing battery management system for automotive systems. What are the tools, techniques, what we use in the industry for developing such applications. So with that being said, let us just continue to our session without further ado. So let me just share my screen. I hope I can share my screen.
Sir, please share your screen, sir.
Yeah. I'll share my screen. And I believe my screen is visible.
Yes, sir.
Yes, sir, please continue.
Yes, thank you. So already ma'am has given a very brief approach, brief introduction about me. But let me just introduce myself again. My name is Raj Kumar. I work as a senior applications engineer at VA Solutions Bangalore. And VA Solutions test automation company, which is focused on many domains such as automotive, aerospace, automation, and semiconductors. We provide our expertise to develop our applications for these domains by using a tool called as NI LabVIEW and other products which are focused on a company called National Instruments. And of course, we are a success assured partner for National Instruments, or also called as technical partners for National Instruments. We work with several of NI's, clients, and to provide our expertise on this tool to solve their, problems based on their, problem statements. So, yes. So, what is the agenda for today? So, agenda for today is going to be basically we're going to see what exactly why do we need to go for battery management system, and what exactly is this battery management system. Of course, you already should be you'll be knowing about battery management system, the tools and techniques involved, and what is the system behind it. Okay, those things you'll already be knowing, and we'll be seeing about a tool, okay, which is primarily used in several of the um, industrial companies to develop this battery management system, both design, development, testing, as well as deployment. Okay, and why do we need to go for that tool? Instead of going for a normal programming language, there is a specific tool available in industry. Yes, and once we use the tool to fetch data from this battery management system, how can we effectively process them? Right. So this is what we have in our agenda. And I'm sure everyone will be knowing about the core composition of electrical vehicle, because you must be already, I mean, I'm not sure how many days this total FDP is. So out of that, you'll be seeing what are the components available inside. Okay, which is very important for an EV to be running. And I'm sure that three components will be very majorly focused upon. Apart from, there are several other important components. But if you see, predominantly three important components will be a traction battery. Okay, that is the battery pack for the electrical vehicle. And the second one is going to be the power inverter or converter, because mostly your load, okay, will be a motor, and motor cannot be directly switched on and switched off by using your battery, a switch, and a motor. So it's not that easy. So instead, you need to have a intermediate circuit, okay, that's going to convert the power from the battery to something which is compatible for electrical traction motor. Okay, mostly it will be AC motor. So in order to convert the battery DC from battery to AC, okay, we'll be having a inverter, and this will be having components specifically used for automotive loads, right? So battery, inverter, and third one is going to be obviously is going to be traction motor. And of course, all these three things will require you to have some specific tool to both design, to design, develop, test, and deploy. Okay, so there's going to be several tools available in the market to focus on this. But one common tool helps in our industrial equipments, industrial environment, to focus on all three areas. Maybe not for all design, develop, test, testing and deployment. Okay, at least testing. Okay, will be focused on all three, right? So that's what the tool which we're going to focus on. And today my agenda is going to be focused on traction battery, focusing on traction battery, right? So we'll be focusing on traction battery. What kind of battery do we use? Then how to effectively manage that battery? What is the important components is there that we are going to focus on? So why did we do, what is the need for a BMS? In order to focus on the requirement for a BMS, we need to know why exactly people, why exactly engineers needed to go for BMS. Okay, so there was a reason, it turns out, that is previously in automotive systems, everyone focused on using lead acid batteries, right? And lead acid batteries, though they were heavy, okay, they didn't have much disadvantages. But only disadvantage it has, it was very heavy in order to provide significant power. Okay, because automotive systems were ranged from your battery bike, okay, your bike, and it went more complex as the length of the vehicle increased. The from starting from the bike to tanker lorries. Okay, tanker lorries also required to have several electrical systems inside it. Okay, maybe electrical wirings for lighting, for navigation, okay, for several other purposes. So in order for powering it, okay, they basically use lithium-ion batteries. I mean lead acid batteries. But as the size of the vehicle increased, the size of the battery also increased. So this is going to add more, weightage to your vehicles. But instead, what people did was, instead of relying on electrical lead acid battery, what they did was, in order to carry the same level of power, but by decreasing the weight by 1/3, essentially by 1/3. Okay, so the weight was need to be reduced. All right, so that's the reason. If you see, instead of going for lead acid battery, people migrated to go for lithium-ion battery, because lithium-ion battery could store more energy per weight. As a matter of fact, it can store anywhere between 2.5 to 3 times the same weight of a lead acid battery. Okay, so that's the main advantage for going for lithium ion. But even though it can store more weight, it can store more power for the same weight 3 times, it had drawbacks. Okay, this is a very good advantage, to be honest. But challenges were there with respect to lithium ion batteries. That is, 3 problems. That is, one is charging, discharging, and thermal problems. Okay, so in case of charging, even if you overcharge a lead acid battery, okay, over voltage if you apply, at least of course it's not like too much over voltage, but significantly higher voltage even if you apply, okay, it's not going to immediately damage the lead acid battery. Okay, there is a mechanism in lead acid that is can do cell by cell equalization with little damage automatically. But in case of lithium ion battery, okay, over voltage in a single cell, even a single cell, if the over voltage is applied, it can cause extreme damage. And if one cell gets damaged, it will be like, due to the sheer amount of heat generated, it's going to totally rupture the whole battery pack itself. Okay, lithium is a volatile and combustible element. So without proper handling of the lithium, okay, it's going to damage the whole battery itself. So this charging has to be very carefully considered, and there should be external circuits and embedded systems which is going to monitor the charging rates, charging levels, those things. So it's an extra added component which had to be included. But due to the advent of technology, due to the rapidly evolving technology, it was not such a complex task to be implemented. And also discharging also, if you see, you can dry discharge a lead acid battery, okay, to up to 0% of state of charge. Okay, and it's not going to have that much of damage. Little life cycle damage is okay, tolerable. Okay, but lithium ion battery, if you continue to discharge it, it should not go below a certain voltage. Okay, going below which it will have life cycle damage. Okay, its life cycle, the life length of the life will be reduced. Okay, duration of life will be reduced. Okay, instead of working for 5 years, if you continue to discharge it to voltage below certain level, it's going to work for 3 to 2 years only against marked maximum voltage, marked life cycle. Right? So even though it can carry more power, it had these drawbacks. Right? And in order to address only, people have to go for specialized circuits. Okay, maybe a microcontroller or microprocessor with additional circuitry. Okay, in order to monitor the state of the battery. That's why engineers introduced a circuit called as battery management system. So battery management system is an external circuit, okay, which is going to basically introduce a circuit along with probably an embedded system with sensors, which is going to monitor voltage across individual battery or current through the the whole system, and also the current temperature of the battery. Okay, these 3 things are going to be monitored by this battery management system to probably to either calculate certain secondary values like state of the charge, state of the health, or it could also hold the data like what is the total current life expectancy of the battery. Okay, those kind of things. And also it will also have features which implements protection for a battery systems. Okay, like over voltage, over current, under voltage, under current, kind of protection environments will be introduced inside it, and it will be inbuilt inside this battery management system. Okay. So typically, if you see a battery, this is a block diagram of battery management system. Okay, it's going to have, it's going to start with battery monitoring. Okay, it's going to have a system. It's going to have a system which is going to, monitor certain parameters, primary parameters of the battery, like temperature, current through the whole system, or voltage across individual batteries. It's going to monitor. So this circuit, which is going to monitor this components, is going to be called as data acquisition. Okay, there's going to be several of these data acquisition hardwares. Okay, this data acquisition hardware could be, it could be a ADC inside a microcontroller. Okay, or in case of a very large battery management system, okay, it's going to be a dedicated data acquisition hardware. Okay, from this data acquisition hardware, it's going to, this data from the data acquisition hardware is going to go to a intelligent unit. Okay, which is going to basically have an algorithm which is going to determine the status of the battery based on the data acquired. And from there, it will have, possibly it could have a user interface which says, whether the battery is fully charged, the battery has this much voltage, percentage of voltage. Okay, it can, it will be coming until this point. Okay, it could work for more 2 hours or 3 hours. Okay, that level of, insight could be developed. And based on the state of the battery, it can, basically it can implement safety. Okay, maybe if the under voltage is there, old voltage is there. Okay, some sort of electrical control, maybe whether we need to charge it or whether we should not charge it. Okay, that level of control can be implemented. All right, and based on the data of temperature required, if the battery is too hot, probably you need to implement some coolant, okay, to be circulated. The coolant control, how much coolant should be pumped in per minute, those things can be controlled. These things will typically be either it will be in a battery management system, or we need to implement a system, battery management system on our own, using our own embedded platform. Okay, to implement these, algorithms. But why do you need to go for BMS? So basically, as we already spoke, your lithium-ion batteries are prone to, unbalanced implementation. Okay, because if you take a battery is going to not be, it's not going to be a single block of lithium-ion battery. It's going to consist of hundreds of cells inside. Okay, and each of the cells will have its own internal impedance. It has its own chemical composition. The percentage of chemical composition is going to be different. Okay, which means it's going to have different impedances, and there is a chance that it will not charge at the same rate. So it's important during its charging and discharging, it should all charge at the same uniform rate, and it should discharge at the different same uniform rate. If there is a difference in this, okay, we need to implement something which is going to balance it. Okay, there will be like cell balancing circuits will be there inside the BMS. Okay, additional circuits will be implemented. Okay, not to monitor and control the uniform charging and discharging. If the cells inside the BMS does not uniformly discharge, okay, let's say if one cell is having more charge than other, okay, this one cell is going to be overburdened. Okay, it will be taken from more power from it individually compared to others. Right, so that is going to be catastrophic for one single cell. So instead, each of the cells should be, discharged equivalently. So by doing this, the health of the batteries will be, extended, which means this battery life will be significantly increased. Okay, and the battery life is increased, the total cycle of the battery, okay, it's going to say that battery capacity is going to be maintained. Okay, and by having the parameters like temperature monitor, okay, you can prevent the explosion fire, okay, significantly. So this is why BMS, even though it's an additional component involved in the battery management, battery system, Okay, this is very important component for lithium-ion battery. It's not like there is no requirement for us to implement for lead acid battery. Okay, if you want, you can have it as well. Okay, but it's very important to have the BMS for lithium-ion based systems. And nowadays, electrical vehicles use more lithium-ion based battery pack only, right? And the parameters, the usage of battery management system, okay, is going to be something like this. It's going to monitor the status of the battery, and once monitoring it, it's going to compute some secondary values, okay, based on the voltage acquired. And once data is accumulated, okay, you may need to communicate this data from your battery and battery management system to a centralized unit. Okay, so that this centralized unit will be able to communicate with other systems. Okay, typically your automotive systems, okay, will not only have a battery management system, it will have inverters, it will have motors, and this is like primary components. Secondary components like navigation, say infotainment system and radio. Okay, a lot of other components also will be there inside. So all these things will have its own embedded system, and these embedded systems should be interconnected together, okay, to communicate with each other. So in that case, there will be a specific communication protocol will be there, okay, like RS-322, RS-485 in case of industry. Okay, but since we are talking about automotive, in automotive systems, we'll have specific protocols like CAN, LIN. Okay, so these are protocols, okay, which will be inside the car, okay, not to communicate with intelligent systems, right? So maybe BMS will communicate to a inverter unit that this much power is still available. Okay, depending on that, motor will your inverter will draw that much power. Right. And next is during charging, during the charging or discharging, okay, we may need to implement protection units. Okay, and let's say in case the voltage supplied to from the charger to the battery is high, okay, we may need to implement a overall voltage protection system, and that is going to be done by something just connected to the battery terminals. That is going to be a battery management system. Okay, so or else under voltage, under current. So in case of lithium, nickel, magnesium hydrate batteries, which is also not very common, but still it's being used. So in that case, pressure of the battery is going to be monitored. And there are other components like battery connected to load, and also energy recovery. Okay, those things also will be specific to electrical vehicles. So these things will be monitored and controlled by BMS. And when you say battery management system is going to monitor certain parameters, what are the parameters it's going to monitor? So it's going to monitor three components, three key components: voltage, current, and temperature. Okay, so these are three components is going to be just monitorable by using some sort of sensors. And also you can monitor coolant flow also. But what you cannot directly monitor is you cannot monitor state of the charge or state of the health. Basically, state of the charge is nothing but if you take your cell phone, okay, you'll have cell phone or laptop, it's going to have its own charge level. Right, that is called a state of the charge. And that is going to be a parameter which cannot be directly computed, which cannot be directly measured, because that is going to be a component of your voltage current. Right? So this is going to say the amount of charge is still available inside the battery. Whether 100% of the total power available is available, or 0% of the total power available, or anywhere in between. right? So this is going to be monitored by the state of the charge. So state of the charge measurement is not direct. We have some methods, okay, which is going to do it. Okay, either you can directly try to measure it. Okay, if in case of direct measurement, you will measure voltage and current, and you'll try to calculate by using some standard formulas. Okay, for that you need to know what is the maximum capacity of the battery. Okay, when you know that, you can measure the direct measurement, or else you need to map. Okay, we have something called bookkeeping estimation, where you will say, okay, if this is the voltage and current, okay, you can say that this is the particular voltage. So basically you will map the voltage at 0 voltages. Okay, I mean, you will map the voltage at 0%, and again you will map the voltage at 100%, and anywhere in between, if it comes proportionally, the percentage will reduce. So you'll store the voltage, these voltages, okay, something called as bookkeeping, and proportionally you'll say, okay, 4.9 volts means it's 100%. I mean, 5 voltage means it's 100%, for example. And if it is 2.5 volt means it's 0%. So 50% in that case means it's going to be 3.75 voltage. Okay, somewhere in between. Right? So it could be found like that. And we have other systems like adaptive systems, okay, which makes use of latest technologies like neural networks, SVM. Okay, it's going to collect a lot of data with respect to that battery during its operation. It's going to collect this data, and it's going to map between the voltage levels at different points to the estimated percentage. Okay, the battery percentage. And sometimes we'll use combination of these, one of these two. Okay, 2 out of 3. So there are several types of methodologies are available, okay, which you can take a algorithm from somewhere in the research papers. So this is state of charge. Okay, well, there's one more important component which should be monitored. That is state of the health. Okay, state of the health, as a matter of fact, is going to be not the exact as state of the charge. Okay, state of the charge is a function of how much more your battery can work. Okay, that is its total life. Okay, the health of the battery. An example what I could say is, when the battery was installed, maybe its current capacity at its installation, okay, it's going to be 100 ampere hour. Okay, so consider that 100 ampere hour is going to be 100%. Let's say due to wear and tear, after some time, you see that it's not going to always give 100%, 100 to 100 ampere hour. Okay, but due to constant degradation, you see that it's only able to supply 80 ampere hour. Let's say after 2 years. So now the current 100% of state of charge is going to be 80 ampere hour, not 100 ampere hour. So you'll now consider that state of the charge of 100% is going to be 80 watt or 80 ampere hour. The current capacity is going to be 80 ampere. And in future, okay, it's going to become 60, 50, 40, 30, like that. It's going to keep on degrading. Right? Typically, this is the life cycle of a state of the health. Okay, when you newly buy the battery, okay, when you install it in any component, maybe it's in automotive or anywhere. So for some number of cycles, you can see that it's going to work for 100%, okay, of the original, level state of the charge. But as you see, this is applicable only up until 500 cycles. Okay, first 500 cycles, there is 500 charging, discharging. It can supply the 100% of the original capacity, right? But as and when this number of cycles increases, you can see that it's going to reduce slowly to 90, 80, 70, at 100. Until 500 cycles, you can see that it's going to work 100%. But once it goes to 1000 cycles, you can see that it's dropping to 50%. Okay, then it's going to go exponentially. Okay, at 2000, okay, it's going to go 30%. Okay, and then at 300 cycles, 3000 cycles, you can see it's 20% of the original capacity. So let's say this is a 1 kiloampere per hour. Okay, at first it's going to work 1000 ampere hour. Okay, then slowly it's going to reduce, and discharging and charging cycles, when it reduces to 3000, okay, it's going to supply only 200 ampere hour. Okay, which means people need to replace it. These things, there should be a system which is going to monitor all these parameters for us, and it should not be monitored manually. Okay, some intelligent unit should be able to make this data stored and get derive insights for us. And also computing of other components, like what's the maximum charge and discharge current during this operation. Okay, maybe let's say when we drive the electrical vehicle, okay, we need to know when we apply certain speed, how much of the maximum charge is going to be drawn, or how much discharge current is going to be drawn, or how much energy has been delivered since the last charge. Okay, once after you remove it from the charging station, up until the next charge cycle, how much energy has been delivered or expended from the battery. And also the indication of the health of the battery, internal impedance, okay, also needs to be calculated. And charge delivered or stored. Okay, charge is going to here act like your fuel indication. And fuel indication is very important for any automotive system. It could be internal combustion engine based, petrol based, diesel based, or electrical vehicle. Okay, because range anxiety plays a vital role in the market of EV. So once this much charge is available, we can plan it out. Or else, like previously for electrical vehicle, petrol based vehicles, even if we lose petrol, there's a chance that we can there's always somewhere nearby some gas station is available. People can get it and refuel them, or somehow someone will pass by and they'll have some extra fuel, or there's a chance you itself will have some fuel, so we can refill it up at least until next gas station. Okay, but range anxiety and the battery charging times, okay, say that you cannot really do that in this case. Okay, for that also we need to look for some alternatives. Right? So other parameters also needs to be monitored correctly. Okay, while monitoring these components, okay, you can also implement certain production systems, okay, like overcurrent or over voltage. Let's say if charging is taking place too much, okay, too much due to over voltage in the unit, over voltage in the power supply. Okay, we need to constantly monitor whether that voltage is being passed Okay, something like that. Okay, over voltage, over current, under voltage, under current, under temperature. Temperature is also a very important component of the BMS because lithium-ion battery is very volatile. Okay, so these parameters will be monitored, and production systems with respect to this will be implemented. And for lithium magnesium hydride batteries, when you charge it, okay, the pressure inside the battery is going to be increased. So that is also going to be monitored. Okay, so this is the reasons for going for BMS. Okay, so if you have any questions up until now, please feel free to ask me. Next, you'll see topologies. Then we'll see a tool, okay, which is going to be used for implementing these stuff. And of course, if you have any questions, you can drop in the chat box as well. Yeah, I think someone has raised their hand. Okay, then I don't think anyone has any questions. I don't think. If you have any questions, you can unmute and ask, or else you can just type in the chat, and whenever I see it, I'll answer it.
So, excuse me, sir.
Yes, sir.
Sir, actually, you discussed about the various protection scheme, that is over voltage protection and over current protection.
Yes.
These are the things will normally use in the internal part of the battery. So, what is the external thing, what parameters we should consider in order to increase the lifetime of the battery? Like if the power supply what we are giving to the battery is not quality one. Likewise, we have any other parameters externally, sir?
Externally.
So if it is voltage and current means it is an internal thing what we are measured from the battery output. We are protection. Apart from that, any other parameters is there, sir?
Normally, temperature will be considered.
Yes.
Because temperature is going to affect the chemical, composition of the battery and the action inside the battery.
One more thing, sir, is there is any coolant arrangement provided for batteries, sir?
Depending on the
temperature in the prescribed limit.
Yeah, depending on the size of the battery, we may or may not need to go for coolant or exhaust systems. Okay, if you are talking about electrical vehicle, obviously it's going to be high powered. So in that case, either we need to go for coolant based or mostly coolant based, or else we can have an exhaust system. Okay, where it's going to be mostly coolant based in case of electrical vehicle. Okay, it's going to have just like engines are going to have coolants is going to flow inside. Okay, for electrical vehicles, surely we'll be having coolant based circulation system inside in order to extract the temperature from the the battery units. Okay, so it's going to be that it's going to carry the power upwards. Okay, why the monitoring systems using neural network SPMS are called as adaptive systems? Can you please elaborate why adaptive? Okay, in case of that, basically, if you see adaptive in the sense it's going to keep on, adjusting, right? So that's why we call it as adapt, right? And neural networks are basically, machine learning algorithms or deep learning algorithms, you can say neural networks, Okay, it's going to collect data like voltage, current, and temperature, and based on the data, without implicitly saying this is what the formula is, this is going to learn, okay, based on the behavior of the battery, okay, based on the behavior of the charging and discharging of the battery, it's going to find out what is the the state of the charge and state of the charge of the battery, and it's going to deduce how much voltage is available. And moreover, it's not going to be constant based on the operation. Okay, it's going to keep on learning, and today one particular voltage will be 60%, but as the operation keeps on, as the wear and tear keeps on reducing the battery life, the voltage will shift. 65% voltage will shift from 4.5 volts to something else. Okay, and if you have a bookkeeping methodology or direct measurement methodology, it's going to stay constant pretty much. We need to revise it manually. Okay, but when you have these systems, artificial intelligence based systems, okay, it's going to automatically reduce it. Okay, it's going to keep on learning. One example could be, your cell phones are nowadays, having AI inside the battery itself. So, if you keep on operating it, there is a chance that even though it shows 30% of battery, it will abruptly, switch off. Okay, and the next time you charge it, it will calibrate itself. Okay, so automatic calibration, okay, we can say like it's adaptive. So that's why we call it as adaptive system. So there are plenty of algorithms are available. You can, these are some of the examples what I can say. So any more questions, please drop it in the chat box. We will proceed for next. And of course, there are different topologies when it comes to BMS. Okay, and very especially for electrical vehicles as well, the type of electrical vehicles which we use. Okay, that also significantly affects the type of topology. So basically, when you say BMS, it's going to have an implicit unit, maybe a microprocessor or microcontroller, and optionally, it may also have an operating system. Okay, but it's very optional. It's not like really necessary. Okay, but it could have it will have an intelligent unit with capabilities of communication. Okay, and it will also have certain additional circuitry which is capable of measuring voltage, current, and temperature. Okay, but there are certain topologies which makes it really easy for us to make measurements. Okay, because due to sheer component of the the number of cells available in the battery, okay, we need to make measurements from each and every cell. Right, so there are different types of topologies available in that case. Okay, 3 in fact, but the first one is not that much used nowadays, even though it's the most economic one. But management of the centralized is going to be very very hard. Right, so we have 3. And the first one, if you see, it's going to be called as centralized BMS. Okay, basically, it's going to have a central master control unit, or you can say it's a processor. Okay, which has analog. Basically, you can say it's a processor containing additional circuitry for measuring voltages. Okay, along with signal conditioning, maybe. And from here, it will be connected to the cells. So when you have a battery pack which has multiple cells, we need to make measurements of voltage across each and every cell, and so it's going to be generating. Then you need to make measurements, okay, voltage, current, and temperature, and you need to communicate it to, let's say, a central master unit. Okay, this is central master control unit in the sense that it's going to be for BMS. Right, so this, even though it looks like a very good centralized monitoring system, okay, the problem with this is you can see that it's going to have a lot of wires, And let's say central master unit is in somewhere in some other location, you need to carry one pair of wire per cell, okay, to a very long distance, and it's going to make it very bulky. Okay, and in case of automotive systems, you're going to have per cell maybe like 400 to 500 cells, and this will not be a very good bargain. So centralized BMS is not much used. Okay, basically it may be used in an UPS system maybe, but not for electrical vehicle. There's one more thing called as distributed BMS, okay, which will consist of a smart battery, a smart cell, okay, meaning individual cells will have a integrated circuit embedded in it. It's going to monitor voltage, current, okay, temperature for individual cells, and this smart cell is going to have a place to connect something to it, okay, so connect wires to it, okay, enabling us to communicate it via some protocols. Okay, it could be RS-485. Okay, or in case of electrical vehicles, maybe CAN, LIN, or FlexRay, or any other specialized protocols, or automotive, Ethernet, anything. Okay, this is the elegant way to implement the BMS, but this is also the costliest way to implement, because each and every individual cell will have intelligence. Okay, but this is the most elegant way to implement it. And your master unit will be connected to all these cells by using a protocol, right? So an example of this could be, you can have something like this in electrical vehicle also. Okay, or in case of, you can have something like this for other type of electrical vehicles like trains. Okay, individual compartments will have, individual batteries. Okay, so individual batteries could have, electrical vehicle is very, a very good example for this, right? But there's also a third way. There's also a third way, that is, modular BMS. Modular BMS means, it's not going to implement intelligence into all 80 cells. Rather, it's going to split. Okay, so it's going to have one more intermediate intelligence. Okay, it's going to have one more intelligence in between, and it's going to communicate. It's going to be connected to the battery via this intermediate system, make the measurement, okay, and send this measurement to the central processing unit. Okay, this is a very good example for electric systems that are used in your trains, electric trains. Okay, so individual compartments can have varied number of cells, and individual compartments could monitor it and send it to a common unit via protocol. So cost is effective here. It's cost effective. Okay, and there's a trade-off between cost effectiveness as well as wiring complexity. So this has everything in between, right? So modular BMS is typically used in mass transportation units, and if not a large number of cells are going to be implemented, okay, you can say that distributed BMS is going to be used. Both of them are used in both places. Okay, depending on the architecture which is defined, okay, it's going to be implemented. But this is the most costliest way to implement a BMS. So now is the time which we are coming for, um, the tool which is typically used for this implementation part. There are many tools available in the market, I agree. Okay, specifically used for other purposes as well. Okay, I'm sure everyone will be aware of such tools. But there's a tool which is specifically used for data, acquiring data from external world, bringing it in, analyzing it, processing the data. So that tool is something called as LabVIEW. Okay, and LabVIEW is a tool specifically used by engineers and scientists all around the world. Okay, and LabVIEW is not like very normal programming language. Okay, I'm sure some of you would be already aware of LabVIEW, but let me just tell you, LabVIEW is a tool, okay, which is used in several industries. Then the main reason is because it's not like a conventional programming tool. Okay, it's a graphical programming language. So that's why we call any system which is designed by LabVIEW called as graphical system design. So the reason for going for LabVIEW is LabVIEW, the programming language is, it's a graphical programming tool. Number one. Number two is it is capable of connecting with several of the hardwares. It talks with several hardwares. Okay, and the hardwares will be basically instruments, okay, instrumentation, computer-based instrumentation. Okay, in order to make measurements. Okay, it will be acquiring the data from that hardware and bringing it into your computer. And also several domain-based toolkits, okay, specifically used for several domains. Okay, maybe it could be automotive, maybe it could be for electrical vehicle, maybe it could be for other ecosystems. Okay, it's going to have certain toolkits available, okay, in order to make it possible. And also specialized hardware required for specialized domain is also going to be available as a part of LabVIEW ecosystem. Okay, if you see even before building the battery, if you want to simulate the characteristics of the battery, okay, there is a battery simulator is also possible by using NI ecosystem. Okay, so here we have this battery simulator. Instead of building the battery by using the chemicals, you can first simulate by using the equations which we have available. Okay, first test it properly, then you can give the order for manufacturing and going forward. So starting from simulation, design, okay, testing, all these things have been done with LabVIEW for past 50 years or so. But what does LabVIEW stand for? Okay, LabVIEW stands for Laboratory Virtual Instrumentation Engineering Workbench. Okay, basically LabVIEW is a tool is used for building your own instruments. Okay, it's used to make measurements. If you have real hardware with you, okay, it's going to have that hardware outside your in real world. The hardware is going to be there. It's going to get data from the real environment. Okay, then for processing it, automating the processing, okay, you'll get the data from the real environment and bring it to your computer for further calculation. Okay, not only that, you can also customize the appearance of the instrument. Okay, if you take an oscilloscope in our usage, okay, that oscilloscope is going to have only one appearance. But when you want to use an oscilloscope for something else, you may need to buy something else. Okay, but if it's a virtual instrument, the appearance of the the instruments could be heavily altered, okay, depending on an application. That's why virtual instruments are called as virtual instrument software is going to be called as LabVIEW program. It's going to consist of both software and hardware. Typically, it will be used to imitate physical instruments. Okay, and this is the programming environment of LabVIEW. Okay, you'll have two windows. One is called as front panel and block diagram. Okay, when you take any instruments in real world, you will have front panel. Okay, so which will get inputs and outputs from the user, and there will be logic behind that instrument. Okay, which is basically needs to be developed by us, and that will be developed in the block diagram. So an example, what I can say is, So in real world, we used to use a lot of calculators previously, but nowadays we really don't need to have a specific external calculator, because with the click of your start window and go to calculator, search for calculator. Okay, you're going to have an application inside your computer which is going to have the same features as your calculator. Okay, it has all these three things. Okay, and as a matter of fact, this is also not even available at Casio, calculators, graphing, stuff. So it is available in this one. So just give me a moment. So yeah. So yeah, this is what the program is going to consist of. And front panel is going to be, the place where you build the user interface. Okay, you can customize it to however you want, but more importantly, you can get the input and output from the user. Okay, you can say what's the voltage we have to measure, or what is the voltage we have to set. So something like that you can set it by using the front panel. Okay, input and output. Okay, when you take an Android app, okay, it's going to have several inputs and outputs which you can interact, right? So that is going to be front panel. And block diagram is like back end, front end, back end, you can say. Okay, back end is the behavior of that is going to be done by something called block diagram. So the reason why the applications work is someone has programmed it in such a way. Okay, so the reason why the YouTube works when you click on the app and just browse it is someone from the YouTube company has programmed several layers. Okay, both front end and back end. That's why when you click a button there, like button, okay, so it communicates with the server and it again gets back the response. So similarly, in the domain of electronics or electrical engineering, so when you want to program something, okay, we need to write the code for it. But instead of going for traditional programming, okay, so LabVIEW encourages engineers and scientists to program by using graphical programming approach. Since engineers are very good with flowcharts, okay, LabVIEW programs will signify a flowchart based programming. Okay, it will have some continuous wires to it which we can program. So let's try building a very small program. Okay, I have a LabVIEW program here. So I can just go to File and New VI. As I already told you, LabVIEW VI is going to consist of both front panel and block diagram. Okay, front panel is a place where you will write the, bring the input and output, and block diagram is a place where you will define the logic behind the algorithm. So let's say we're going to multiply two numbers. Okay, so let's say we're going to multiply two numbers. Okay, we need to write a program. It's going to get these two numbers. Okay, then perform this addition function, then update that value into another variable. So this is equal to C is equal to A plus B. Okay, but for that, first we need to create A, B, and C. So front panel is a place where you will, create these variables, or in LabVIEW we have certain name for it, which you will see. And once you do it, okay, you can define where this connection will take place. So in order to create these variables, okay, we don't call it as variables in LabVIEW. Depending on the direction of the flow of the data, okay, we are going to call it as either control. Okay, control means inputs to your program, and indicators are going to be called as outputs from your program. So let's say we want to give inputs. Okay, in that case, we'll right click on your front panel, numeric, and we have something called as numeric control. The controls are used to give input to your program. So once you pick and place it, you can see that this is highlighted as that black color, which you can rename it. Okay, and press Shift and A together. Okay, to name it as A. So once you place something in the front panel, you can see that that thing will be appearing in the block diagram. So when you have A in your front panel, A will be available in the block diagram. The reason is once you give the input, it needs to be processed in the block diagram. So when you place something in the front panel, input and output, it's going to apply in the block diagram as well. Okay. So I can right click and I can place one more. And now I'll have this something like this. So A and B. And after I finish the addition, I need to view the output. So output cannot be viewed in control. The control is just to give input. In order to see the output, we again go to numeric. And instead of control, we go for indicator. The A, B, and C. Now, front panel is a place where you can right click and you can access the data types. Okay, so numeric means numbers. You have numeric controls indicators. Okay, these are not restricted to only this type of controls indicators. You have other various type of, because LabVIEW is graphical. Okay, they provide several types of controls indicators depending on the type of instrument which you're going to access. And you can see the difference in your block diagram between the controls and indicators. So controls means the data is going to come from left to right. The arrow mark on the control is going to be on the right hand side, which means the data is coming outside. Okay, and for indicator, the data is going to be accepted inside. Right? So now, in order to process this, I cannot process this in front panel. I have to process in the block diagram. So in order to process it, I will right click on the block diagram. And you can see that there is no reason for me to remember any syntaxes. Because here everything will be arranged for depending upon the data type or depending on the functionality. So let's say I want to multiply. Okay, I need to search for a numeric function because multiplication is an operation of numeric. So I have numeric function here. And you can see here. So this is a numeric function. So now, in order to communicate with A, B, and this and C, LabVIEW programs are basically going to be called as wiring. Okay, so in order to wire it, I just need to move my cursor. Someone has unmuted. Yeah, thank you very much. Okay, I just need to connect this A. I just need to connect, click on this terminal. Okay, the LabVIEW, when you place something in the front panel, okay, the same instant object will be available in the block diagram. Someone has unmuted. Please check it. So when you place something in the front panel, the same object will be available in the block diagram. And this is a front, it's a control. And the same instance of the control will be available in block diagram. And this is called as terminal of the control. Okay, basically you can consider LabVIEW programs are electronical or electronic circuits. Okay, because in order to program in LabVIEW, we just need to wire the terminals together. You can consider this as a circuit component. This is a terminal to an instrument. This is an instrument itself. That's why it's called as virtual instrument. You can connect A to this terminal. So the connection is made. And similarly, you can connect B to this terminal. So the connection is made. And after that, okay, the output of that multiplication, okay, should be connected to C because we need to see the output to C. You can connect this output to C. Now you can run this program continuously again, or run this program. Okay, by clicking on this run button available on top. Of course, yes, not execute the LabVIEW program, you need to click on the run button. Before we click on the run button, we can just give some input to here. 10, 20, and click on the run button. Okay, and that will fix the stuff. Okay, so 10 into 20 is equal to 200. Right? So let's say this is one test case, which needs to be given. But let's say you have multiple test cases to be given. You can click on this instead of run button only one program runs the program once. You also have an option for run continuously, where you can change the values. Okay, during the runtime and get the output. Right? So there's also like a lot of debugging features available in LabVIEW with minimal programming requirements. Okay, so if you want to know how the program actually works, you can click on this highlight execution program function. Okay, available on the toolbar. You can click on the run button. You can see how the data actually flows through the the LabVIEW code. Okay, it slows down your program and sees how the data flows through your wire. That's why LabVIEW program is called as data flow programming. The flow of data signifies how the program works. Once you display the diagram, highlight execution, you can see the program will run as fast as you can. Okay. So similarly, there are several other toolkits available as a part of lab environment. You can see that numeric is available. Okay, you can also, if you want, you can also have Boolean data type. Okay, Boolean input and output, true or false data. Okay, that also can be bought inside. And also, like if you want to give the data as a string, okay, true or false. Okay, that also can be bought as something like this. Okay, and also you can store data in the form of array, cluster. Okay, a plethora of options are available. Okay, give me a moment. Yeah. So this is how you program using LabVIEW. So yes, lab view coding style will be, fully graphical. Okay, if required, you can of course export inputs and outputs as well from other programming tools like C++, C, MATLAB. Okay, there are several um, methods available for that. But it's efficient to write lab view program. Not always, but 95% of the time, okay, lab view code will be itself sufficient, and the code itself is going to be fully graphical. And input and output also, if you see, it's going to be fully, GUI based, where you can build your own GUI, okay, depending upon how you want to display the data. And what exactly is the advantage of doing all these things for engineering and scientific community? Okay, the first advantage of lab is program the way you think. Okay, basically, if you see, most of the time, engineers will be planning, okay, with respect to something called flowchart. Okay, and other programmers typically tend to convert these flowcharts into programming, syntaxes. Okay, but LabVIEW itself is like flowchart-based programming. So the amount of time taken for us to convert this flowchart to flowchart programming is going to be very less amount of time. Okay, so it's going to reduce the programming effort which is required. And other thing is connect with any hardware. Okay, there are several hardware portfolios available in industry as part of used for interacting with the hardware computer-based instrumentation. Okay, not to acquire data from real world. So LabVIEW is, it's not just a graphical programming tool. It is actually built to interact with several types of hardwares. Okay, and bring the data inside a computer environment. So for that, there are several, functions available inbuilt in the LabVIEW environment to make it happen. So as you can see, there are some set of functions available in the LabVIEW, called as measurement IO functions, which hosts several types of driver functions available for several types of hardware. One such type of hardware is called as DAC-MS hardware, okay, which will act like a data acquisition hardware card, okay, to get data from your real world. We also have specialized type of input, not specialized types of hardware like oscilloscope, function generator, TMM, DC power supply. Okay, it's going to be available. This is for measurement type. Okay, you can find that there are several drivers available as a part of LabVIEW to interact with such hardwares. Right? Even if you see these hardwares are NI-based hardwares, okay, so it will be like, okay, so these are NI-based hardware, so NI software supports NI hardware. Not exactly. If you see, even if you have a third-party hardware as well, okay, in LabVIEW, not only can you interact with NI-based hardwares, so there's something called instrument IO, and you can see that there are several third-party companies which develop the LabVIEW drivers which is required for their clients. Okay, so if you see, like in this example, this display, Agilent is one such company which provides LabVIEW drivers for most of their instruments, because LabVIEW is deeply ingrained into the instrumentation industry. Okay, several of the instrument providers provide drivers, okay, in order for it to talk with LabVIEW. Okay.
Chat box lo போடுங்க feedback link send பண்ணுங்கன்னு சொல்றேன். Chat box lo போட்டுருங்க.
Any questions you have? I hear people talking. Okay, it was fine. So I thought someone has question. So if you have questions, please let me know first. Okay, apart from that, it has several drag and drop libraries, just like how we see it was easy to add two numbers. Similarly, there are several drivers, drag and drop libraries. Okay, where we don't need to remember the syntax for how to process. Okay, it's going to have it. Okay, and as I was saying, okay, several types of programming languages can be integrated inside lab. Let's say someone has already written some code or algorithm in other programming tool. They don't want to reinvent the wheel basically. Okay, but let's say if they're new to get the data from a hardware, only the processing is to be done by other programming tools. Yes, of course, we can do that. Okay, so let's say if they already done a program in, let's say, for example, MATLAB. So there's there's a function inside the lab view which enables you to interact LabVIEW and MATLAB together. Okay, and most importantly, after interacting with this hardware, let's say you want to store this data from the hardware into some sort of file. So your tool must have capability to log data. So file IO capability is also available here. Okay, apart from that, you can also create your own user interface because GUI is the front runner for front panel. Okay, you can customize it according to your needs. Okay, and finally, Lab is not only used to program in your laptop or PC. Okay, you can also program certain types of real-time computers or specialized computers. Embedded systems can be programmed by using LabVIEW. Of course, not all the embedded systems are supported, but some of the embedded systems can be programmed by using LabVIEW. The operation behind it can be easily programmed. And not only embedded system, which has real-time OS. Okay, so FPGA can also be easily programmed by using LabVIEW graphical tool. Okay, meaning normally FPGA, if people program, they make use of VHDL or Verilog. But LabVIEW FPGA, by using LabVIEW FPGA, you can program the code in the LabVIEW itself, and there will be a compiler which will convert your LabVIEW code into FPGA based code. And we don't need to know how to program in VHDL or Verilog. This is going to do it for us. So let's see how it's very beneficial for LabVIEW to interact with. One second. Yeah, sorry. So right now we are seeing the capabilities of LabVIEW as a software, but still we are not sure that how BMS and LabVIEW still integrate, right? So the main reason why we need LabVIEW for BMS is the most important reason is LabVIEW can easily integrate with hardware, and when it can easily integrate with hardware, it can get parameter data from, let's say, a data housing system, which is going to acquire voltage, current, and temperature data and bring it inside a processing. Everything good? Okay. So just only hardware is not going to be sufficient. My software is not going to be sufficient. Okay, your tool should be readily be able to interact with several hardwares and bring the data from the real world inside your environment, programming environment, so that you can extract the data, useful information from the data collected and derive, let's say, certain sort of insight, or maybe convert the data to something which can be used for certain type of processing. Okay, so for example, let's say if you want to, you'll be acquiring voltage current data, and let's say if you want to compute certain parameters like state of the charge, state of the health, or something like that. Okay, you need to have some programming environment is going to employ that algorithm. So that could be LabVIEW basically, right? So these are the you can say this could be a potential, okay, of where you can use LabVIEW. And as you see, LabVIEW can easily integrate with several hardwares. Okay, and we have different types of hardwares which can easily integrate with it, which can collect data from this external environment. And the programming of hardware typically is, normally people will say, okay, if you want to program a hardware, we need to know C, C++. Okay, or nowadays Python is also gaining traction. MATLAB, even though it's specifically used for computation purpose, nowadays certain hardware providers provide drivers for it. Okay, but still it's not very efficient because now only people have started using MATLAB for hardware, so still it's not very fast. Okay, but LabVIEW was built keeping in mind hardware integration, and in industry still it's the fastest implementation for hardware based programming environment. Okay, if it involves hardware, LabVIEW is the go-to tool. Apart from that, generic programming tool like C, C++, yes, still people use C, C++ because of its fast communication, okay, and fast processing, right? But programmers can program using C, C++, but we are talking about specialized domain engineers who are focused on battery management system or electrical vehicle based system design, inverter design, who are not very familiar with syntax of C++, C++. Okay, but they are familiar with instrumentation. So in that case, they can typically, with very steep learning curve, okay, very quick learning curve, they can know how to acquire voltage data by using graphical programming tool, and they can sequence on how to make that acquisition. Okay, with minimal learning curve. And LabVIEW is one such course as too. There are several types of data auction hardware available, okay, depending on the ecosystem which we're talking about. Okay, it can easily integrate with several type of families of data auction hardware. But people normally what they'll think is, okay, so if we have this much type of ecosystem, so people say, okay, different programming, different hardwares will have different programming methodologies. But to be honest, to program any type of family of DAC hardware, okay, only one type of programming environment will be used. That is this type of DAC MX hardware programming. To program an industrial DAC also you'll use the same thing. To program a USB based DAC also you'll be using the same thing. So you'll be used to program for learning purpose. There's one type of hardware, okay, which we're going to see a demo for. Okay, that is also can be programmed by using the same methodology. Meaning, for any type of application, you will use the same type of DAC. Right. So now let us show you how we can use a data auction hardware to bring data inside a computer environment. Okay, and I have now I don't have industrial DAC per se, but I do have a family of DAC hardware, okay, called as my DAC. which will work the same way as any other DAC. So my DAC is actually a USB based DAC. The moment I connect it, okay, I'm going to get a pop-up here. And once I get that pop-up, so you can see that commonly used instrumentations, okay, is going to be, available as a software-based front panel. Okay, I don't need to know programming to access this. It's going to have commonly used instruments. Okay, but of course, my DAC is not going to be, industrial based DAC because does not have specifications based to industrial based tools. Okay, so let's say if I use an oscilloscope, okay, it will have the oscilloscope's appearances, okay, inside the computer environment, but it cannot really replace an oscilloscope per se. Okay, because if you see, it can maximum measure up to in terms of 5 volt scale. Okay, and my DAC can basically maximum measure 5 volts of voltage through oscilloscope, but a normal oscilloscope can measure up to 100 volts or maybe 200 volts also. Okay, depending on the type of oscilloscope which you're looking at. Okay. So if you want to measure more than that, of course, you can still do it using MyDAC also. Okay, by employing some signal conditioning circuits, additional circuitry. Okay, you can see here, you can see that I have this different types of MyDAC connected to my system. Okay, which I can select it here. Right. So oscilloscope is connected, and you can see that for oscilloscope there are channels available. Okay, AA0 and AA1. And now let's say I want to generate some signals. Okay, for battery management system, okay, you can say that I just need to collect data from external world. Okay, and I analog voltage.
మా ఇంట్రెస్ట్ అందాక ఒక 1 నుంచి చేసింది నా 3 ఇయర్స్ పడుతుంది అంతే ఇలా చార్జ్
Yeah, I'm sorry about that. I got disconnected because some reason. Anyone had any question? Yeah. So if you have any question, please do drop it in the link and drop it in the chat. Okay, I hope everyone can see my screen. So this is the oscilloscope. And then next is going to be, let's say if you want to generate something. Okay, in that case, inside your DAC, okay, you'll be having a function generator. Right? So from a function generator, you need to, you can basically, if you see the DAC hardware, it's just going to be a block of hardware. Okay, that's it. Okay, so it's not going to have any user interface on its own. But if you want to interact with it, your DAC hardware needs to be connected to your computer, and your computer will control it. Okay, and the computer will have the front panel, okay, with which you can control it. Right? So that we need to know either we can use this inbuilt software front panel, or you have to go for something which can be able to program this environment. Okay, let's say for the matter of this explanation, I have just connected the function generator and oscilloscope together. Okay, so both of them will be the same hardware only. Okay, actually, I can show you the picture of my deck. Okay, so this is how a MyDAC hardware typically looks like. Okay, it will have this analog input, analog output, digital output will be there. And it also has a DMM if you want to make measurements of voltage and current, high voltage and high current, not much high voltage and high current. Okay, it's going to have its own specifications, okay, which you want to consult. Okay, typically in industry, we don't use MyDAC. Okay, we'll be using other versions of data vision hardware. Okay, this is just for learning sake, we can use it. Right. So for the sake of explaining about how computer-based instrumentation can be used for BMS, I'm going to just generate some data using this function generator and bring it inside my computer environment. Okay, so using a function generator here, I'm going to generate some sine wave, and I've connected this function generator's terminals in the real world to your oscilloscope. Meaning when I apply some voltage in the function generator, it's going to be seen in the oscilloscope as well. So which is what I see here. So I applied 1 volt peak to peak VBP sine wave of 100 hertz. So here I see the same thing. If I adjust the scale, I can see that 1 volt peak to peak, which is what I see. If I change the frequency here, I'll be able to see the frequency change here as well. And this is not simulation. Please don't discard this as simulation. I've actually made the connection in the real world. So if I remove the wire at the outside, you can see that if I make some disturbance, you can see that disturbance will be reflected in the display of the oscilloscope as well. So this is how the computer-based instrumentation will work like. So right now we're just generating some voltage and applying it in the oscilloscope. Okay, but this could be potentially, it could be a battery. Okay, with signal conditioning. So one terminal could be connected to battery. One pair of terminal could be connected to battery, and one pair could be connected to a current sensor, and it could be monitored. Okay. So right now, if you see, these things already have some appearances. Okay, but how do I programmatically, modify it according to my own needs? I don't want each and everything like AI0, AI1. Okay, everything is here. So in that case, that's the reason why if you see the instruments appearances have all been developed by using LabVIEW value, which means the collection of data for our BMS, instead of relying on this already available instruments, I can basically make use of LabVIEW to do it. Okay, so in this case, if you see, we are just performing some arithmetic operations, but I really don't need to do the same thing. Okay, so if you see, I have DAC hardware available. I have already connected to my computer. And in order to extract certain data from that hardware, okay, I have certain functions available in the LabVIEW to interact with such hardware. So if you see, since it's a DAC hardware, I have some drivers which will interact with DAC hardware. And there are programming, methodologies available to program it. But if you're a beginner, you really don't need to go with such low-level program. Okay, so since LabVIEW is typically used for engineers and scientists who don't have much programming experience, in order for them to start that journey, LabVIEW will have certain functions which will enable them to start from beginning. Okay, we call these functions as express functions or express VAs. Okay, so express VAs will look like this. Okay, it will have a blue color background. So if you pick and place them, it's not going to have a programming, methodologist associated with it. Okay, rather you just need to make a configuration out of it. You just need to select what are the measurements which you need to make. Or if you're going to generate, you just have to mention this generate. So not a lot of programming methodologies will be involved. So it's going to ask whether you're going to acquire or generate. So let's say I want to acquire. I'll mention as acquire. And whether I need to acquire an analog input or counter input or digital input. So typically an analog, DAC hardware is capable of working with anything. So it can either work with analog input or analog output or anything. So here I just need to select what hardware to program it with. Okay, so here I need to work acquire data from AI0. Okay, so I can just select AI0 here. I give finish. If I need to select more, I just need to select more, more out of. And here, as of now, I don't see doing any explicit programming. Okay, I just configured it to my requirement, and I just selected certain questions, and that's it. And this drop down box is available on how to make the measurements. And I'll just give OK. And before I give OK, I can also test whether it's working fine or not. Whatever configuration I made, whether it's fine or not. So it's going to make the measurement and it's going to show me here. And once I give here, this block will write a program for me. You'll write a program for me. I don't need to write anything for it. So this will collect the data. Okay, this is software part. Hardware part, we need to make the connections to the terminals available in the DAC hardware. So you need to consider other things like what are the signal conditionings is available. Those things you need to consider. So once we make it, it's going to be, connected together. Right? So to view the output, there are many ways. Okay, you can use a waveform chart or waveform graph. Since lab is graphical, okay, there are different ways you can visualize the output. Okay, here you can see numeric indicators available. Okay, or you can use a waveform chart. Okay, graph functions are also available. Okay, since I'm getting from a hardware, if I want to visualize the data better, I can use a waveform chart. Okay, if I run this program once, it's just going to give me one data. If I just use it run continuously, it's going to continuously acquire some sort of data. Right now, I don't have anything connected, so you can see that it's just going to show me noise. So typically, for battery management system, we require some sort of data acquisition hardware or embedded system which is capable of data acquisition and acquire the data. And typically it will be a ADC which will acquire the voltage data, and you need to convert that voltage data to ADC data to voltage. And sometimes it will be raw voltage. Okay, maybe we need to do some calibration. Okay, and sometimes voltage will be acquired from a current sensor, and that current will be converted to proportional voltage, so on and so forth. And temperature also will be connected to voltage, so that also need to be connected to temperature. So all these things should be logged. So typically, if you see, file layer functions are available inside LabVIEW, which enables you to log the data into some files. Okay, you can use spreadsheet files, Okay, you can use text files, binary files. Okay, there are several things that are available. Right. As an example, okay, so since we don't have an actual, battery, okay, which is hooked up with electrical vehicle, okay, we do have a file, okay, which logged data of the file, okay, which is collected during one of the electrical vehicle testing, okay, battery testing, okay, during the runtime. So we have certain logged data file, data here. So from which we can show it to you. So BMS battery management system data has been collected. Okay. And typically right now data acquisition is seen, but how we can process data. So either we can implement certain algorithms inside the BMS itself to process data, or you can bring it to a central processing unit, and there you can process it. So LabVIEW also has certain algorithms inside, okay, certain libraries, drag and drop libraries. Okay, you can see that electrical power, EV power test. Okay, you have certain thing called battery processing. Okay, there are certain tools which enables you to get some meaningful data from, process meaningful information from the available data. Right. So we're going to see an example of how these functions have been used. Okay, but right now we don't have a battery. We don't have, actual hardware. Okay, but one thing we do have is we have an actual data collected from this hardware by using one of the hardwares, industrial hardwares. We collect the data over a period of time, and with that data, we'll be able to compute certain, required information. But data is available in the form of file, okay, which is available here. So different profile, discharge profile of the EV is available. Okay, EV drive profile, EV peak power, at the peak performance, how the discharge is happening, and for a hybrid vehicle, how the charging, discharging is happening. Those things are available. So someone is muted. Please do. I mean, if someone is unmuted, please unmute yourself. Please mute yourself. Yeah. So any open source available by VI for simulations related to battery and discharging? Okay. So yes, of course, LabVIEW is a proprietary tool, okay, which is used in industry, but it's a very, what you can say is it's a very trustworthy tool, okay, which is used by various industries for their implementation of, implementation of their applications. Trustworthy tools is used by several engineers and scientists all in the world, and it's a proprietary tool, of course. But one thing which is there is, even though the hardware is, the LabVIEW tool is proprietary, NI LabVIEW hardware, okay, if you see, it is integratable to several programming languages. Okay, it's not like it is only interactable in LabVIEW hardware. Okay, I mean LabVIEW software. Okay, you can use it with C, Python, any other tools. But those are open source, of course. But NI does not have any simulation tools open source. But one thing is, LabVIEW does offer a trial period. Okay, a 7-day trial period, or if you create a if you create a NI account, it's going to offer you 45 days free, okay, which you can get most out of the, So there's also already a program, okay, this is developed by using LabVIEW. So if you see the first portion, okay, focuses on getting data from the file. Okay, this is the data of the testing done on the battery pack, load testing, that is during the driving of the EV, how the the charge from the battery gets discharged, how it reduces, those things can be seen here. Okay, that data is collected from the file, and we are trying to process the data from the that BMS, and we extract the voltage and current data, and we feed it to certain function. Okay, this function is called as so this what it does is this gets the current waveform and it integrates it to Coulomb. Okay, we don't need to implement this formula per se, because LabVIEW already has this block which is available here. Okay, EV power test battery, which when you give the current waveform to it, okay, it's going to convert it into charge. Okay, and this is going to be, if you feed the power, okay, it's going to convert, it's going to give you the joule. That is the power energy. Okay, so these are the secondary data which you can derive from by using these functions. Okay, so I have retrieved the voltage current data. By using this data, okay, you can get the charge and the other parameters. So let me run this. So I can just browse. Okay, I have 3 types of drive profile available. Okay, EV drive profile. Okay, you can see that the data from the EV is getting retrieved from the file, and we're able to play back the data. So this is the voltage, current data, and from that we are computing what is the power data, energy, okay, charge, okay, those things we are able to compute. And this is happening in as like a playback also you can do, and you can also show all the data at the same time. Below, if you see, okay, it's going to have like a graph. Okay, voltage, current, and here if you see the charge, discharging. When you switch it on, you can see it's going to the maximum, and from there, due to continuous running, okay, charge expenditure, okay, you can see that it's going to slowly reduce. And even though this charge and the energy is going to look similar, you can see the scale, okay, is going to be different. Okay, charge and energy is going to be different. Okay, this is going to be in terms of joules, and this is going to be in terms of charge. This is for normal driving profile. Okay, you have other 2 profiles, peak power. Okay, there the scale is going to be very highly, exaggerated. I mean, it's going to be very high power. So you can see the data here as well. So voltage and current only you get from the measurement, but from that voltage and current data, you're using LabVIEW to compute the power, charge, and energy. And further, you can use the available methodologies like which can be used to calculate the state of the charge and state of the health. You have to implement an algorithm, or you can use an existing algorithm. You can feed the data to it, and you can calculate the state of the charge and the state of the health. Okay, and you can display it in LabVIEW. Okay, right now, for this example, we have not done state of the charge and state of the health. because different types of algorithm are there. Okay, and the implementation of algorithm is not very easy. But once you have implemented it, you can use like lab use GUI to implement, voltage, display. Okay, you can name one of the display as, let's say, charge of the battery, and I can say, how much percentage. Okay, 100% to 0%. Okay, battery charge. This can be optionally implemented by yourself. But in order to make this processing happening, okay, first you need to have a data acquisition hardware. That is what makes the data come from actual, real world to your hardware. So one more, yes. Yes.
About 5
Hello?
more minutes, sir.
Oh, 5 more minutes to complete, no?
Yes, sir.
Yeah, ma'am, I'll surely complete. I'll surely complete.
Sure. Thank you.
The other type of testing, like you can do battery testing. Okay, you can put the battery to load test. You can measure what is the voltage current. Okay, and discharge measurement you can make over a period of time. And right now we have seen how to calculate charge energy. And it's not like no one has used this technique. Okay, so if you see one company, okay, if you see called as Primus Power, several companies have used, but if you see this company has given us case study, okay, in the NI website itself, that they have implemented BMS, okay, for by using the NI platform and Compact Trio, one of the NI's embedded system platform, okay, to implement a BMS system for their battery. Okay, they used LabVIEW, Compact Trio, and their product called as Energy Pod. Okay, just basically battery with BMS inside. Okay, internally you can see the battery will be there, and the battery monitoring system will be there, the battery management system will be there. Okay, the communication between this also will happen. Okay, it will be a centralized system. I mean, individual will be having each and every thing will be having a BMS. Okay, it's like a modeler, you can say. Okay, each and every cell battery will be having a BMS. Okay, and also the master BMS also will be there. Okay, through which everything will be communicating. Okay, and the centralized inverter also will be there. And totally energy management system also will be present. Okay, everything will be implemented. And to monitor the performance, okay, they are sending all this data to cloud. Okay, lab you can also use for implementing IoT also. Okay, and not only this ecosystem is used in computer, industry. So one university in Spain called as Mondragon Universitatia, okay, they have implemented BMS using LabVIEW and a student hardware called as MyRio. Okay, they have implemented it. The students have implemented it. Okay, a battery management system for lithium ion and LabVIEW. Okay, with ease of programming and the embedded system available. Okay, they use LabVIEW, MyRio, and one more IC for which is specifically used for battery monitoring. Okay, they implemented modular system. Okay, they'll have battery cell. Okay, individual cells will have individual IC will be acting like a battery management. Okay, and it just communicate the data to master BMS. So they'll be having cells, they'll be having this battery management system IC, and this will be connected to your MyRio here. Okay, this is how MyRio will look like. Okay, it will be connected to a protocol. So this is a SPI protocol which I use. And this is the setup. And this was implemented not by engineers and scientists. This is done by students. Okay, so what they told was they were able to implement a BMS in short time. Okay, because they're already familiar with LabVIEW, and since LabVIEW is easily integrated with hardware, they were able to implement not only the logic, they were also able to implement a good user interface along with other features. Okay, so that's all it is. I'll just share my contact in the chat box, and of course, I'm open for questions. If you have any questions, please let me know. So if you have any questions, please do post in the chat box, or I think as ma'am told, we can conclude the session if you won't have any questions.
Dear professors, any questions? Thank you, sir. Thank you so much, Rajkumar, sir. You have given a very good presentation in lucid manner how to use this battery management on LabVIEW platform. Thank you so much, sir, for your technical inputs. I hope the participants have enjoyed this session a lot. On behalf of GRG Polytechnic College and IC department and myself, we are very much thankful to you, sir. We should say convey thanks to Mr. Nagaraj, who has introduced you people, yourself and SK Raja, who is going to handle going to handle the session in the afternoon. We are highly thankful to you, sir. You and Nagarajan, sir. Thank you so much.
The pleasure is mine, ma'am. Thank you very much for the wonderful opportunity
Thank
here.
you, sir.
And
I request all the professors to fill the feedback link. I think by this time we all hope filled the form. I will have the afternoon session by 2:30. Kindly join 5 minutes before. Thank you so much. Thank you, Rajkumar, sir. Thank you so much.
thank you.
Thank you, professors. We'll join for the lunch and again join for the session by 2:25. Thank you all.